Today I'm going to teach you how to build a Legend of Zelda style game with JavaScript. We'll start by creating a map using a map building tool I developed called MapperMate. Then we'll go over some top-down game basics such as how to scroll a scene and animate sprites. We'll learn how to create and interact with multiple enemies, then continue by adding leaf particles and some finishing touches. Now chances are, if you're watching this, you like to learn. And in the back to school fall productivity spirit, that brings me to today's video sponsor, Skillshare. Skillshare is the largest online learning community for creatives, with thousands of classes led by industry experts across programming, video games, illustration, design, freelance, productivity, film, and even more. In short, Skillshare can help you take your career, skills, hobbies, and passions, or side hustles to the next level. They have a number of learning paths as well to help master specific skills, including the one I've been following as of late, design a 3D video game in the Unreal Engine. The first 500 people to join Skillshare using my link in the description will get 1 month of Skillshare Premium free. So join today and make this fall season your time to become an amazing game creator. Now let's get right on into creating our own Zelda style game. So to start developing our game, we need some sort of game map. And there are a number of ways in which we can create a game map, and the one that might come to mind first is just programmatically getting this onto our screen somehow. Maybe we export this as an entire image, and then we import it into our game. Another way is to use something like Unity, Godot, but then it makes things a little difficult for creating this game map within the realm of JavaScript like we're doing. So to create our game map, we are going to be using something called MapperMate. This is an app I developed myself because I was using Tiled before, and it was just really difficult to create a map like this using Tiled. I wanted something that was easier, so I made MapperMate. Cool. So let's just get right on into it. How would we create this map? Well, we want to go on over to mappermate.com, and once we're here, we can click this button to start making maps. And I'm already logged in, so we're going to see all my maps right here, but if I log out, this is what you're going to see. And you can either log into your account with an email address and password, or with GitHub. If you want to sign up for an account, just click this. It's totally free to sign up. I'm not charging you unless you want multiple projects. But for what we're doing here, you don't need to pay anything. So just sign up for a free account. I'm not tracking any of your stuff either, like usernames and any of that. Just get that free account, log in, and you're going to be presented with this screen right here. So when we're on this screen, you probably don't have any projects yet. We want to create a new project by clicking this button. And to create a new project, all we need is a project name. We're going to call this Ninja Adventure. And then we want to select a particular tile set. So these are a couple of free tile sets that I pulled in from various artists across the globe. You can see the artists right here. We can click visit them. This one is by not Ninja Boy, Pixel Boy, a great artist, and I really recommend donating to them. So you can contribute now if you want to help donate towards their cause and their asset pack. But we're going to be using that exact asset pack right here. So we want to select that asset pack, and you're going to see this pop-up show right beneath it. This says a tile set has a pre-made map available, and if we select this, we're going to have our entire map populated with what we want to use for our own game. So if you basically just want to get to the programming, select this option right here, and then you can skip over this whole next section in which we're going to be building out a map. But if you want to learn how to build out your own map, maybe expand upon what I already built to create a full game, then you would want to deselect this and just start from a base. And you can always come back, create a new project, and add the Zelda template later on if you would like to start from that. So it's no issue whether or not we start from it. Let's just go ahead and start without it for now. So I'm just going to select this. We can hit create project. And now we're going to be presented with a blank MapperMate map. And I want to go back for those of you who just want to go to the programming. If you want to go straight to the programming, you can head on over to this templates tab. You can see a couple of the maps that I already created. One from my last tutorial, which is a 2D platformer. And then the one for this tutorial, which is going to be a Zelda top-down kind of template. So you can see what the map looks like right here. If we wanted to use this, we just click this button, and it's automatically going to import all the layers that I created from my own making of this map. You can see them all right there. And then you could export this as normal. So go ahead on over to the export section if you would like to program things, but if you want to learn how to create this, we're going to do just that now. So how would I go about creating this map from the blank project in which we created called Ninja Adventure? Well, we are given a blank canvas to work with, and you're going to note on the top right section over here, we have what are called tile sets. And a tile set is just an image, but it is laid out in a very particular way so that we can grab certain parts of this image. Each little tile that we see right here is 16 by 16 pixels large. And since the image is laid out in a perfect way, we can grab little pieces of 16 by 16 squares and then draw them out on our screen. So that's kind of how tile sets work, is it allows us to grab certain parts of our image, and when we combine these certain parts of an image together, it allows us to create a really detailed map like what we saw earlier right here over with the pre-made template over in MapperMate. So let's start creating based off that template. I think that is going to be the easiest way to show you how to create a map like that. What I'm going to do is I'm going to side by side my windows. I'm going to have one window open so that I know what I'm working with drawing-wise, and then I'm going to have another window open that shows my template so I know exactly what it is I want to work off of. So I just have MapperMate open over here within Chrome. I'm going to click the template section, hit the Zelda template, and then I have this map in which I can reference and draw my new map off of. And I might want to zoom in a little bit, and I think that is good to go. So over in MapperMate, I'll try to expand this a little more. I'm going to erase these little dummy tiles that I put on the screen, and we can do so by hitting the eraser button right here. We can expand this by either changing the value right here to something like 5. That increases the size of my eraser, and now when I click and drag on top of those tiles, we are getting rid of them. Pretty cool. And I'm going to scroll on over to the side here and select my brush tool. And I want to start just by creating this little edge right here on the path. And it's a little confusing at first how these terrain tile sets might work, but you're going to get the hang of it real quick, especially with me guiding you along the way. So I know this piece right here within my tile set matches up with what I see over here within our example. And that example is probably about 4 tiles from the left of the screen. So if I wanted to try to be as exact as possible, I would go 1, 2, 3, 4 tiles over, and then I could click and drag to start creating what we see over here. Now, if we want to create a perfectly straight line, of course we would have to keep our finger steady in this case and just drag down with our mouse or a trackpad, but we can also use the line tool right here. So if I were to click this, you can see I can create a whole line of whatever tile that I have selected. I can undo that with Command Z, but if I want to extend this little path downwards, I would click, drag, and now you can see my line is going to go wherever my mouse goes. So off to a good start. The next tile I want to focus on is underneath this red tile, and all these red blocks are collision blocks, by the way. We are going to get there, but underneath this tree is going to be a corner piece. And a corner piece is just going to give us a little bit of curve so that we can start creating some tiles for the top part of our path. And that corner piece is right here above our side piece. So I'm going to grab that, and I only need to put it in one spot, but if I click right on the very top of our current path, you can see that connects perfectly. We're creating some sort of pathway for our village to live on. And now I can grab one more tile to the side of that, and I can begin extending that with the brush tool. So we're basically creating this top part right here. If I want to start extending it down, you can see I'm using a corner piece. And now we have a little bit of a dilemma. So behind this house, it immediately curves inwards. And if that's the case, I don't really want to go down like this. I would rather use another corner piece to make a really tight little corner right here. And I think that is looking good. But we're going to run into a bit of an issue soon. So preemptively, I'm going to select that corner piece we put down, and I'm going to create a little diagonal line right there. But I need something to connect these two, you can see there's a little bit of a gap right here that doesn't really connect the two corner pieces. And we need to look around within our tile set with what might work for that little gap. And to just give you a heads up, a cheat code on where that gap is, it's going to be this piece right here. So these 4 pieces are corner pieces, and they're going to be your best friend when creating terrain like this. So if I were to select this one top left corner piece in the center and place it right here, you can just see that it matches up perfectly. This is like a inner corner piece, I would say, something along the lines of that. But when we place it right there, you can see it looks great. So we're going to keep moving onwards. We are currently at this corner piece right here, but now we need something in which we can start moving our tile down. So we need one more inner corner piece. I could place that to the left of this one, and then scroll on back over to this side. And this piece right here, you can see matches up with the corner piece. And I think we only have one of those in place, but you can kind of get the idea. Your main terrain tiles are going to be this section right here, and then these 4 inner corner tiles. And we're going to need another one. We're going to need the bottom left corner tile. I could place that right there, and then I can start using this top edge piece. And then I need one more corner tile, so I'll grab that one. Then I want to start moving up, so to move up, I'll grab this edge piece. And yeah, that's basically the gist of how we're creating terrain with a tile set. If I wanted to fill this in, I would just need a full piece right here, put that in place, and we are looking great. So that's kind of the main idea for creating some sort of terrain. I don't really think there is too much else I would want to show you in this case, but for now I'm going to put this on a time lapse, and I'm going to show you exactly how I drew out this entire section with this tannish background and then the beigeish background. So pretty much this section right here with this red box, maybe it's a little easier if I make it blue. This section right here with the blue box, I'm going to put that on time lapse to show you how I did it, but I'm pretty much only going to be using those exact pieces in which I went over. So let's go ahead, put on time lapse, and you'll see how it is done over here. Okay, I'm going to stop the time lapse here because this is where I want to kind of show you a cool trick on how to improve your map. So let's say that we have some general terrain laid out. It's not exact to what we see over here, but it's pretty close and it gets the general idea through. Now we have this section that is filled with the same beige tiles, and right now that's encapsulated by this whole perimeter. Let's say that I want to fill all this in. Well, of course, we could select this middle tile right here and just draw until we fill in the whole thing. But that is really tedious and cumbersome. We don't really actually want to do that because it sucks. So instead, I created this fill tool in which we can select, and pretty much any area that isn't filled in yet. So any area that has black tiles, we can hover over that. And you can see if we are to click, we're going to fill in that entire area. So save us a lot of time right there. We created this perimeter, now we can fill it in by clicking, and our map is looking great, very close to what we have over here. And we'd want to do the same thing for the surrounding area, but using a different tile, this darker tannish one. If I were to select that, we still have area, which has not been filled in yet. So if that's the case, we can select our fill tool. That's going to highlight. We can fill it in. We have this little box right here, which we can also click. We have something that looks pretty darn close to what we see over here, creating a great game map right now. So to continue on with the terrain portion of this, we have different terrain right here. We have pretty much tiles in place for our little village. And if we were to want to add tiles within our map, we would have to scroll around our terrain tile set until we find exactly that. And I think when I created this tile set, yeah, I actually put those tiles near the bottom of it. So we have something similar to what we were just working with, but a little different. But it's nothing that we can't handle. So if I were to start creating this section right here, let me brush that in, with our tiles in front of that little gate, how would I do that? Well, simple. I would just grab that exact tile piece that I want, and then find where I would like to start drawing. And right here matches up with what we see over in our template. So I'm going to add that in. That is a corner piece. I have another corner piece here, so I'll add that to the side, and then I can fill it in with that middle piece right there. And I want to extend it downwards a little bit. And then I want to start curving things off to the side eventually. But let's fill in what we have right now. And you can see I'm just running out of space. If we want to add more space on our map, well, we have this rows and columns section on the bottom left of the MapRemate interface. So what we can do is we can change the amount of rows to a greater value. So let's say instead of 20 rows on our map, I want something like 40. That's going to give us a perfect square. If I hit 40, hit enter, you're going to see that now our map size has increased. So we have a lot more room to work with here. So we're going to keep on moving this tile set downwards, but we do need a corner piece. So like I said, we pretty much either need one of these pieces or we need one of these inner corner pieces. And we're going to be using this inner corner piece right here so that we can start turning our pathway to the left. So grab that bottom right corner piece, and now we can start extending that by selecting this bottom piece. Or maybe it was the top piece. Yeah, the top piece. I get a little confused sometimes too. I'm just going to extend that with my brush tool. I can use my line tool because as you can see, it extends all the way to the left-hand side of the map. So I'll switch over to the line. And now I can draw this wherever without messing up because of unsteady hands. And then I would want to switch back to the brush tool. Anytime you click on a tile set, it's automatically going to put you into the brush tool. It's just kind of a little shortcut that I found handy because now I just want to brush with that one instance. But yeah, you get the idea. I can start connecting this pathway by adding more corner pieces. If I wanted to create something longer right here, I would use the line tool. And then I would need another inner corner piece, just a different one, to start going downwards. And that is kind of the gist of adding a new kind of terrain to our map. You just kind of need to know when to use corner pieces and when to use tiles that actually extend the length of your map, when to use corners and so forth. But there's really nothing else to it than this. It's a lot easier than trying to draw all this out programmatically with code. So that is why we are using something like MapRemate. So similar to before, I'm going to go ahead and put this on a time lapse, but I really encourage you to try to build out a map yourself using this tile set that we see right now. Pretty much just this square right here and this smaller square right here, the inner corner pieces, to create a pathway similar to what we see within the template. So let's either fast forward, watch time lapse, pause the video, whatever you need to do, and let's continue making this pathway right here. Okay, so that pathway is pretty much done, and I want to focus on this section to just reiterate. If we wanted to fill in this section right here with all the blank tiles, we know we created a perimeter. We don't want to draw everything in manually with the brush tool. We can just simply select our fill tool using the tile we want to fill everything in with. Select those black areas, and now we're good. But you'll see that only works on the areas that don't have any tiles in place. So if we already have this tan tile right here, we just need to fill it in with the brush tool or delete it with the eraser tool. But yeah, we're looking great with just this. So I'm not going to go over the rest of the terrain. You kind of get the idea. The terrain is probably the most important part, honestly, for creating a good looking map because it's going to help guide your user throughout your game on where they might want to go and where they need to go. So that's the basics behind creating some sort of terrain, and you can see there are a lot of terrain tiles in which we can work with here for water, ice worlds, grass worlds, deep forest, and so forth. So feel free to create the map of your dreams using what I just taught you right here. But we're not done with the map creation process just yet. There's a lot going on in this map right here, and we want to add things like decorations, trees, houses, and so forth. So how might we go about doing that? Well, if you look over here, I included a couple of tabs that are imported automatically for us when we selected the Ninja tile set. So if I click one of these, we're going to get things like buildings, and there's one more tab on the far right, which is going to give us characters in which we can place on our map. Now, in order for everything to export correctly within the realm of JavaScript, it's very important to note that we can only have one tile set per layer. So each of these tabs up here represents a tile set. And I am currently within the characters tile set. You can see if I try drawing on our layer, new layer 1, which uses the terrain tile set, I'm just not able to do so. And I had to code things that way so that we could export all of our data correctly into a good base starting point for our game. So if we wanted to use a different tile set, let's say we want to use a decorations one, simply we would click add a layer, and then we can draw on top of our map again using this new layer though. So let's add some houses in here. I want to replicate this first house in this little alcove area. To do that, I would click and drag the house that I want, find the exact location in which I would like to draw the house, and then I would click, and it is as simple as that. So there are a couple of locations that use this exact same house. There's one here, there's one here, there's one here, and I think that might be it. Actually, there is one over to the right on this side. That looks great, but we want a couple more houses filled in. Let's give our game some variations. I'm going to select the next house in line. I know I want to draw that there, right here, and there's going to be another one. I think it's right there. I'll add that in. And then we have a couple more variations going on. Let's select this red one. I think that looks really cool. Add it in the necessary locations. There's one on the far right. Add that there. And that is how we're going to add houses into our game. Now, you'll see that there are some variations on the houses used in the template compared to what I actually have right here within this map we're creating. And if we look really closely within our tile set, the row beneath the houses contains variations for our houses. So we can do things like add different doors, we could do things like add windows, decorations, chimneys, and so forth. So why don't we do that now? Let's say I want to add a closed door for a few houses. I'll select that closed door, and then on top of the open door, in which I want to draw this on, I'll click, and now we have some variation to our houses. So I'll try to find all the spots on our template that use that exact door. I think that is all of them. And let's add this other one as well, giving all of our homes some nice variation here. That looks good, but I do want some decorations on top of my buildings as well to continue bringing out the liveliness of our game. So we have a window decoration right here. You can see that matches up with what we're looking at over here on the template. It's just, I don't know, something nice to add onto our house to make our game have some variation. So let's say I wanted to add that window right here to this house. If I click, you're going to notice it does not look right, because when we are trying to layer some sort of tile that has a transparent background, like this window right here, it is deleting the tile behind it if we were to draw it on the same layer. So we just deleted part of the house and replaced it with this window, but this window doesn't have the same colored background as our house because we might want to put this window on multiple buildings. And if that's the case, we need to make sure before we place this window on a house that we add a new layer. We can call this something like house decorations. And if we want to rename a layer right now, the only way to do that is with Control R. So hit Control R. We can call this house decorations, just so we know what we're working with. And as long as we have that new layer, well, we're not going to delete anything because there's nothing on this layer. So create that new layer, select your window, and then decide where you want to place it. And you can see that looks perfect. So there are a couple places in which we can put windows or whatever you want to call these decorations for the house. Say that we want this to be our sword store. We'd click right there. And then we can grab our dojo, put it on the red section. So, I don't know, if someone wants to train their sword fighting skills and so forth. That's kind of how you could do it. And same thing with the chimney. We got multiple spots in which we can put that, add decorations to the front of our houses. As long as the decorations are on a new layer that is on top of your actual house layer, these are going to look great, and you can really customize your houses with that. So next, I just want to show you something basic. How would we add little details like grass, trees, and so forth? Before we get to the trees, let's just do the basics like details. It's pretty simple. I would recommend creating a new layer just to organize things because it might come in handy later when we're developing our game and we need to reference our layers based on what's inside of them. So I'm going to hit Add Layer. And I'm not going to go too far into this, but let's start adding things like boxes and maybe some wagons and some tree stumps. Within the decorations tileset tab, I'm going to search around for one of those decorations, and if I scroll towards the bottom right, you're going to see I pretty much found exactly those. So we have these wagons, some with some contents, some without. I want to make sure that I grab 4 tiles there by clicking and dragging, and then I just need to go to the exact location in which I want to place things. So you can see my tile set isn't exact to what we have already in the template, but it's not a problem because we can just grab other pieces of the tile set, like a box, and place them into the exact locations to prevent people from going into certain spots or to allow people to go into certain spots. And so we pretty much just want to make our map interesting. You never want something just bare because people aren't going to enjoy a dry world. They want a world that represents something in the real life, but better. So honestly, the more decorations, the better compared to less decorations. As long as they're placed in logical spots that make sense and guide your user to the next section of where you would like them to go, I am all for more decorations. So we can do things like add some pots, maybe one on the rooftop. There are going to be little grass decorations in here, little stumps and so forth. Here is a stump. I know I placed a couple of those up at the top. So someone's backyard is not looking too good. And yeah, really just search this whole tile set for some of the things you might want to place, and you can get real creative with the entirety of your game. You can see near the bottom we have some of that grass in which I placed. So I'll put some grass over here on the left-hand side. Maybe this is someone's lawn. You get the idea here. So that is how you would place basic decoration tiles, and I pretty much always highly recommend renaming your layers. So I'll hit Control R there and say this is basic decorations. But the next thing I want to show you is how to create layered trees, because this can get a little confusing. If I were to select a grouping of trees, and I'll select these ones right here, and create a new layer, I'm going to rename this to trees, and I were to kind of try to mimic what I have over here in the template. I'll place a tree here, and I know I want to start layering these. If I were to click on the same layer in which I just drew this grouping of trees right here, you're going to see that I'm cutting off the bottom half. As a result, we want to make sure that we're creating a new layer for every row of trees that we have. So if I were to say that new layer 6 right here is going to have some trees behind what we have already, well, the trees are actually on top of the trees we just placed, but it's not a problem, because if we want to reorganize our layers, we can grab one of them and then just simply move them to the location we want. So I want this one, the trees layer, to be above new layer 6, and if that's the case, now you can see that we're stacking these on top of each other. I don't really like the way new layer 6 looks though, and if I want to move this already stamped grouping of tiles, what I can do is select the select tool. I can either do that by clicking this arrow icon or by hitting V on the keyboard. And what this allows us to do is select a certain part of the layer we are dealing with. So I want to select this tree stamp, which we just put in place. And to do that, I'm going to click and drag over that location. And now what I can do is hit Command X, just like we're cutting out a part of our map. And you can see that disappears, and it's allowing me to select that exact portion. So I can now draw it somewhere else within new layer 6. So let's say I want to draw it right here. I like the way that looks. It's a lot better. I can also draw another one to the side. But remember, every time we're trying to layer this, we need to make sure that we're adding a new layer. So I'd recommend calling your tree layers something like trees 1, trees 2, because who knows how many you might have. But you can also start reusing these layers if you were to have trees in different sections of your map. Like let's say you have a couple trees down here, and eventually you have a grouping of trees up there. Well, these trees at the bottom aren't going to overlap the trees at the top. So let me just exhibit this real quick. We have trees 2. I'm going to place a grouping of trees here, and I know that I want some trees beneath it. I can go to trees 1, which I know is going to be placed behind whatever trees I'm dealing with. Click. And you can see, even though we only have 2 layers here, since the layers are far enough from each other, the stampings that we're using right now, it still works with the layering effect. And that's pretty much what I did over here using the template. You're going to see I only really have like 4 tree layers. But yeah, that's kind of like the unfortunate way in which we have to create trees or layer things on top of each other. So we need to create multiple layers and then move them accordingly to create groupings that look natural. So if we want to continue onwards with the creation of our map, we could do things like add characters by using the character tile set, just placing these guys wherever we might want them. And this is just more like a visual representation for us to know where we might want to place characters on our map. We're not actually going to be rendering our characters out like this when we start programming things, but it gives you a good idea of where you might want things on your map. But I think the last thing I want to show you guys regarding map creation is going to be these red collision blocks over here, because we're going to need those to export our game in the correct manner. These are what are going to stop or allow our character to move through our map. So if I head on over to this button right here, the collisions tool, you're going to see I have two options here, blocks and platforms. Platforms are basically little blocks in which we can move upwards through, but not fall down. They're more so used for platformer games. So in our case, we're doing a top-down game, some sort of Zelda-like game. I want to use the blocks option here. And these are just blocks that indicate where can we not move through. So if our character were to walk into one of these blocks, we would stop their movement altogether. And whenever I deal with collisions within MapperMate, I pretty much always like drawing them within their own layer. So I'm going to go over to Add Layer, and I'm going to rename this Collisions. And then I can start drawing collisions on my map based on where my character should and shouldn't move. So I know I don't want my character to move anywhere within the main boundaries of the house, but I do want to allow them to go into this door area. Therefore, I'm going to draw collision blocks around the door, but not exactly on the door. Same thing for things like boxes. I don't want my character to move through those, not the wagon. Any other houses, tree stumps, doesn't make sense if we walk on top of those. Usually it doesn't. And same for the bottom of trees. We don't want to be able to walk on top of trees or anything along those sorts. And you're going to get an idea for where you should and shouldn't place collision blocks as you begin developing your game. But what you see over here in the template is a great start. You pretty much want to leave the tops of objects open. Like you can see right here for the house, I didn't add collision blocks to that because I want my character to be able to walk behind that section. We're actually going to render it on top of our player eventually. But anywhere where you would never want your player to move, you want to make sure that you add one of these blocks. Because eventually, when we finish our map and we're ready to export our game, we can hit this export button, hit the top-down game option, which we're going to do. Place anything there because I know I just want to exhibit this. It's going to export your project with all the exact HTML, JavaScript, images, and layers that we need to start programming our game. So if I were to click into index.html, you can see that opens up within the browser. Our whole map is rendered out within the realm of JavaScript, which is freaking awesome. And then we can move around with WASD. These are all things that I provide for free using the top-down game exporter. I can move around, and anywhere in which I placed a collision block that is, you can see I cannot go past that area. So our boxes can't go past those, can't go into the house areas, anywhere where we place collision blocks, we just can't move through. And we're going to do things like render out our houses on top of our player and so forth, or at least the areas in which we should travel to. But this is a good start for teaching you the beginning of how we might create a map like this using MapperMate. So either create your own map, or you can use the template version right here. I'm going to start from the template version if you want to be one-to-one. And let's go ahead and start programming. So you finished creating your map. This is where we should be. And if you didn't create a map, well, that's okay, because you can use one of the templates that I've provided within MapperMate to create a new one and get to exactly where I am here. So let's start coding this. What I'm going to do is hit this export button, and we're going to have a couple of options here. The one we want to use for this tutorial is going to be the top-down game option. Why? Because we are looking from the top down onto our map. It's kind of like an overhead view in which we can observe things and move our character around. So this is going to scaffold a JavaScript project for us automatically with some base functionality in mind. So let's open this up, and I'm going to rename this to Ninja Adventure. That's going to be the name of our game. And with this renamed, I'm going to open up index.html to see exactly what our game looks like. So we took all the data from MapperMate, and we are rendering it out within the browser on a canvas element. and I can move around with WASD. And we can't move past a certain point because our collision detection is in place based on where we placed collision blocks. And yeah, this is a great start to our game. I also provide functionality for a pro version of the exporter, where if we were to open this up, you can see that things are zoomed in. We have a sprite in place with animation no matter where we move, and our game scrolls along with our character. It's not perfect because there are some things that we can't scaffold, like making sure that our character can't walk on top of buildings, but it is a great start, saves us a lot of time so that we don't have to go through all this from the very beginning. Nevertheless, this is a tutorial on how to develop a top-down game, so I think we're going to learn a lot starting from this base project in regards to how to scroll our scene, how to move around our world, how to talk to characters, and so forth. So it's going to be a great project, a great tutorial, and this is what we're going to start with. So once you have your project exported, let's open it on up in a text editor of your choice. So I like using Sublime Text. What I'm going to do is grab this folder and drag it on top of Sublime Text. Now I have my project open. I can full screen this, and we can begin focusing on exactly what MapRemade scaffolded for us. So if I look within index.html, we have a basic CSS browser reset right here. We are sizing our canvas. We have our canvas in place. This is what our game is being rendered out on. And then we have all of our JavaScript code down below. So to give you a brief rundown on what's going on here, we are pulling in all of our layer data files, as you can see right here. And if I were to look into one of these files, well, we have a lot of zeros and a lot of random numbers. Each of these numbers corresponds to one tile within our tile set over on MapRemade. So let's say our tile set was decorations. If I were to have a number of, let's just say 1, I would be selecting this very first tile right here on this tile set. And we would see 1 being generated for us within this data file if we were using that one specific one. But we have tons of other numbers here instead, and these just correspond to different pieces of the tile set. And what we're doing is we're looping over each of the numbers within this 2D array. And based on which number we loop over, we're saying render out this specific portion of the tile set onto our canvas over here within our browser. So that's kind of how this whole rendering system is working, is we're exporting these layers, which correspond to our layers on MapRemade, and based on which tile piece we used, we're rendering out that specific tile onto our canvas. So going back to index.html, we have a utils file, some classes here, but really the main file we want to code in is going to be index.js, and I guess also player.js, but mainly index.js here. So let's take a look at that and see what we have going on. So I have a lot more scaffolded code. It's not that scary, I promise. Pretty much everything from layers data down to render static layers we can ignore. That is just the code responsible for actually getting all of our tile set tiles rendered out within the canvas. And one other thing we can kind of ignore is the start rendering function down here. So basically, we're just storing all those layers within a background canvas, and then within an animation loop, we are drawing out that canvas onto our screen. That's what provides our entire background. But we're also drawing out a few more things, including our player. And since we're drawing out our player separate from our background canvas, that is what allows our player to move around without moving anything else within the background. So a very generic overview right there, but if you would like to learn more about how to basically set up a basic canvas, I have plenty more tutorials which start from literally nothing, and I will recommend one of those videos in the description and for YouTube right here on one of the YouTube cards. So let's get started developing our game. What do I want to have happen here first to create something that resembles Zelda? Well, I want to zoom in on our canvas because right now our whole map is displayed. Maybe that's how we want our game to begin with, but in my case, I know I want to zoom in and only display a certain part of my world at a time. That way my user can explore various portions and yeah, not be revealed to everything at once. It'll make our game a little more exciting as we get more surprises, as we reveal more of our map. So that's step number 1, is just zoom in on our map. How would we go about doing that? Well, our map is being drawn with c.drawImage right here. If I were to save this, comment that out and save that is, and refresh, you can see now our background is gone. So of course we want this to be running right here, c.drawImage. But really one function that can zoom in on our canvas code is going to be this right here, c.scale. So c.scale is a global canvas function, which means it's going to affect literally everything drawn out on our canvas if we don't include it inside of the c.save and c.restore function right here. So you can see all this code right here is contained inside of the c.save and c.restore because I only want this portion of code to be affected by the scale. And the scale right now is set to a variable of DPR. It stands for device pixel ratio. And depending on whether or not you have a Retina screen, this is either going to be equal to 1 or 2. And we're just pulling that in directly from the browser. And it's kind of required to make sure that your canvas is rendered in high def, depending on if you have a Retina display or not. So we don't need to focus on DPR too much, but we know that DPR is currently being used for scaling our canvas. And if we wanted to scale this even more, we could add on a small value. Let's say we want to scale our canvas by 2 times the size in regards to what it already is. We would just add a value of 2 onto DPR for both the x and the y coordinate of c.scale. So that's what the arguments are for c.scale, is we have the x scale and then we have the y scale. We pretty much always want to keep these the same because we're scaling proportionally. And if we add 2 on to those values right there, refresh, you can see that our game is scaled in. This is already looking great. I might even scale it a little more by going up to 3 for both of those values. Just give that a save and refresh. And I really like the way this is looking for scaling our game. Now looking at this, DPR plus 3 for the x and the y coordinate here. I wouldn't consider this best coding practice because it is not entirely apparent what DPR plus 3 is. I would probably even name DPR something better because it's kind of confusing to understand what a DPR acronym is unless we really know from the very beginning. So what I want to do here for good coding practices is give these values some sort of variable name. And we know that these are the same value. We have DPR plus 3. So instead of calling this DPR plus 3, I'm going to cut this out of place and call it something like map underscore scale. So I'm using basically constant notation here. When I have one global constant, I pretty much always uppercase my variable name. And then I don't use camel case because everything is uppercase here. I use, what is this called? Underscore case. Snake case. I think it's snake case. I forget, but yeah, I pretty much uppercase all my letters and I connect them with an underscore here instead if it's a global constant that I know I never want changed. So I need to create this constant, but I want to use this constant in both places in which we had DPR plus 3. In that case, I'll replace the second instance with map scale. And all my global constants, I try to put near the top of my file. So near the top up here, I'm going to create a const called map scale and set that equal to the value of DPR plus 3. So now if I ever wanted to come back to my game at a later point in time and edit my map scale from the get-go, I could just go to the top of my file, find the map scale, and change this value right here to see how much I want to zoom in or out of my map. The whole reason I'm creating a global constant here is because I want one specific area within my files in which I can change integral map settings later on in case I need to. So that's what's going on here. We're creating the map scale constant, and then we're using it down below within c.scale. So we're really scaling up by 3 to 4 times the size, depending on whether or not you have a Retina display. And with that in place, we're now scaling in on our map, and we have good practices within code to follow it. So we zoomed in on our map, but the next thing I want to go over is how to scroll our scene. Because right now, we can move our player around in specific locations depending on where we put our collision blocks and so forth. But really, I need to be able to explore more of our scene if our player is starting to move in this direction. We know we have more map available to us down below, so we need to translate our background based on where our player is moving. And there's going to be a bit of an algorithm behind this. I'm going to draw this out to help us better understand. So what needs to happen in order to begin panning our scene? We can think of our scene as this red box. Everything contained within this red box is the displayable area. And as our player begins to pass a certain point within the middle of our scene, we'll say that this is the middle, we need to begin panning the viewable area based on the distance between our player center and the center of our viewport. So what do I really mean by this? Well, I'm going to create a blue square. And we'll just say that this blue square is our player over here. That way I can move this around within my art tool. Let's say that our player moves from their current position past the middle of our viewport right here. Well, if they moved to this point, there is going to be a certain amount of distance between the middle of the screen and the player. We will say that this is something like, I don't know, 20 pixels. So the distance right here is 20 pixels. And what we can do with this distance is say we want to move our viewport camera over to the right by 20 pixels, that exact distance right here. So if we move our viewport over to the right by 20 pixels, well, now we have more viewable area in which we are displaying within our game. And this area over here is no longer going to be displayed. So the whole idea is we want to get this specific distance value between our player center, our player center would actually be right here for the distance value. We want to get this distance value from the center of our screen, and then we want to pan what we're going to call a camera, either to the right, left, down, or up based on this distance. We're just focusing on the X distance right now, but that's the general idea. As our player passes this point, we're going to get the distance between the player and that point and move our scene based on that value. So how do we calculate this distance based on everything that we have within our game? Well, we need to get a couple of values here. The first thing that we need to get is going to be the width of our overall viewport. So how might we go about getting that? Well, let's go to the top of index.js, and I'm going to create a new const up here. And this is going to be called viewport width. This is the first value we want to get. And viewport width is going to be equal to our canvas width divided by our map scale. And let's go ahead and console log that out to see what it gives us. So if we console log out viewport width, refresh, hit inspect, go to our console, you can see that gives us a value of 409.6. But if we inspect our canvas element right here, our width is actually 1024. And the reason this value right here within our console is smaller is because our viewport width is actually going to be the width of our scaled scene. So since we're zoomed in, we only have a certain part of our viewport actually available, and we're saying that the calculated version from that is going to be that 409 value rather than something like 1024. And this is what we're going to need in order to calculate the distance between our player center and the center of our map correctly. So we want to get the center of our viewport width, and we'll create a const called viewport center x, and this will be equal to our viewport width and divide that by 2. We'll console log that out. Viewport width center x to see what that gives us, and yeah, it should be 204.8. And just to prove to you that these values actually match up with what we're doing within our game, we can go down to our animation loop, and right beneath where we're drawing out our player, we can console log out our player's x coordinate. So we should see that when our player gets near the center right here, that we're logging out a value around 204.8. And we'll refresh. Currently we're at 100. If I start moving over towards the right, eventually when I get near the center, you can see we're getting near that value that we initially had of 204.8. So we know that our mechanics are working right here in regards to our viewport width and our viewport center. So really, with that 204 value that we created up at the top, right here for viewport center x, we know that value is correct, and we're getting the very center of our scene right here on the x-axis. So we have that. The next thing we would need to get is the center of our player right here. So we want to get this value, the center of wherever our player is on the screen. And remember, with that, we're going to calculate the distance between the center and our player center. So how would we get our player's center on the x-coordinate? I think the easiest way to do this is to go over to classes and add a new property for the player class. So we have a constructor with an x, a y with height and size, some pretty stereotypical properties for some sort of class, especially within a game. I want to add one more property onto our player constructor called this.center. And a center needs an x and a y, so I'm creating an object right here, and I will create an x property set equal to what? Well, wherever the player is on the screen currently. So this.x, but I need the center of the player. when we are looking at our player currently, this .x is equal to the left side of our player. And this .y would be equal to the top side of our player. So really our coordinate system is starting from the top left of our player. What we need to do to get the center is add on our player's width and then divide that by 2 to move us to the center on the x-axis. We're going to do the same thing for the y-axis. That'll put our center right here. That's basically how this is working. So we're taking the top left of our player, and then we're adding onto it this .width divided by 2. And then we're going to do the same thing for the y-axis, but using the y-coordinate and using our player's height in this case. And that's going to give us the center for wherever our player is initialized on the screen. But as our player begins to move, this is going to stay the same unless we specifically say to update it within our update method right here. So after we update our horizontal position, we check for collisions on both x and y axes. We want to take this .center and set it equal to the new x and y values. All we're doing is resetting the value to exactly what we set it to when we initialized it. So we're saying we're going to update our x and y of our player. We need to take that into account when we're declaring a new center. And we're doing that right here with an update. And where is update being called in the first place? If we look within index.js, down within our animation loop, for every frame of our animation loop, we're calling player.update. And this is what helps us determine how to move our player and whether or not we should stop our player when they hit a collision block. So what else are we doing? We're also updating the player center now. And now that we have the center property available within our player object, what can we do? Well, we can reference it by console logging out player center.x. So let's save that, refresh. We'll open up the console, make sure that we're getting that x value. And there it is. If I begin moving, you can see our player center is moving as well. Cool. So we have our player center. We have the center of our viewport. What do we need to do now? We need to get the distance between our player center and wherever the center of our screen is. So how do we get this distance right here? Well, this is going to be pretty straightforward. Right beneath player.update, I'm going to get a const, and I'm going to name this const horizontal scroll distance. I think that is a good name for this little bar that determines the distance in regards to how much we should scroll horizontally. And what is that going to be equal to? Well, we know that we want the distance between our player center and the center of the map. What is our player center? How do we get that? Well, with player center.x. And to get the distance between this and the center of our map, well, we have that available to us too with viewport center x. So let's console log that out to make sure that we are getting the correct distance in this case. Save, refresh, inspect, you know the deal. And right now, our player's distance from the center is -97. But if I start to move towards the center and I get further to the right, you'll see that value begins to increase. So the closer to the center I get, the lesser the value gets, or the closer the value gets to 0 in this case. That's exactly what we want, because based on this distance value now, we can begin to translate our map. So we are 50 pixels away from the center. That means we want to take our viewport right here and translate that 50 pixels to the right. So we're going to do exactly that now. How would I translate our map? Well, right after we scale our map, we can call another global canvas method. This is going to be called c.translate. This just says, where should we translate our map to before rendering it out? And in this case, we want to translate it based on this distance right here in which we're calculating. So I'm going to put for our x value, in which direction on the x-axis should we translate our canvas? I want to translate it by the horizontal scroll distance. And then for y, I don't want to translate anything just yet. We're going to get there. But for a temporary value, we will put 0. Now if I save this with translate in effect, you're going to notice our scene is translated by default on refresh, but it doesn't seem like it's translating in the right direction. We want to make sure that we negate this value right here. We'll set that equal to a negative. And now, based on our distance, our scene is translating correctly, honestly. It might not look like it because we have all this space over here on the right-hand side, but this is actually what we want. You'll see as I begin to move towards the right side of our screen, we begin to reveal more of it based on that distance value. That is perfect. That is off to a great start, but of course we have this issue over here where we're rendering out just stuff that doesn't really exist. So we never want to translate our scene using some sort of negative value. And what I mean by negative value is horizontal scroll distance should never be negative. This should always be a distance of 0 or greater, because if we use a negative value, we're saying, hey, we want to translate our scene to reveal more of what is over here. But if we look at our map over on MapperMate, we don't have anything to the left of that. So we never want to translate past that value of 0 on the left, otherwise we're going to reveal just nonsense over there. We want to prevent against that, and to do so we're going to use a clamp. And a clamp is just a fancy way of saying, make sure that this value can't go past a certain one. And we can use math.max in this case around the calculation for horizontal scroll distance. So we are basically saying we either want a value of 0 or greater in this case to pan our scene. If this value right here is ever less than 0, we don't want to use it. We want to use the 0 value in that case. So we're clamping it from 0 to greater and onwards, and that should fix our issue with revealing more of the left-hand side of the screen, even though it doesn't really exist. So we'll refresh, and now you can see by default, we're not showing that side of the screen because we clamped that value right there. But if I begin to move past the center, we're revealing more of our scene. And eventually, we want to clamp more of the right side so that we're not revealing anything over here. Doesn't really make sense in that case. But the left is looking absolutely great. We can go to the left to explore more, but we're only going to scroll back to the left if that value is greater than 0 in this case. So let's continue onwards and clamp the right-hand side of our screen, because we only have a little bit of distance in which we can actually scroll before we need to clamp the whole thing. So how do we clamp on the right-hand side? Well, eventually our player is going to go past the center. We're going to get the distance, but this is really the value we need to clamp, is the distance. We don't want this to get greater than a certain point. We just need to figure out what that certain value is. And that value is going to be the distance, or the difference, between our viewport and our actual map width. So our map width actually expands outwards to somewhere over here. And we want to never allow this value right here, this distance value, to be greater than the actual difference between our map size and the viewport size. So how might we get this distance right here? Well, let's go up to index.js, and above everything, I'm going to create a new const. And I'm going to call this map width. So in pixel values, what is our map width going to be? Well, however many columns we actually use within MapperMate times a value of 16, because that is how large each tile is within all of our tile sets. So I know I want to multiply 16 by something, but I need to know the amount of columns that we have within MapperMate for our map. And if that's the case, I can go over to MapperMate, and I can see right here, I'm using 28 columns for my map. That's going to allow me to go back to our code and multiply our map width by 28. So it's not really apparent what 28 is in this case, and if you want to be as clean with your code as possible, I pretty much always recommend naming these variables so that when we come back to them, we know what they are. So 28 in this case is going to be our map calls. Set that equal to 28, and now we can replace 28 right here. And if we want to get even more specific, we can say that 16 is our tile size. I think this is fine for now. I know I'm a bit of a hypocrite for keeping 16, but it's fine, I promise. So we have our map calls, we have our map width. What is 16 times 28? Our map size is going to be 448. And we know that our viewport width was something along the lines of 408. So if we take that value in which we just calculated with our map width, what was that? It was 16 times 28. If we take that value and subtract from it our viewport center x, which we know is something like 408, we're going to get a value of 40. We should never allow our player's distance to get past this point. Otherwise, we're going to reveal parts of our scene that don't exist on the right-hand side of it. So I think I'm going to calculate this as a const. Let's just do it below where we have everything available. I'm going to call this max scroll x. And how did we get that? Well, we got our map width, and we subtracted from it our viewport width. So now we should have a value of 40 right here. If we ever need to check, we can always console log. It's always safe to do that when you're developing in any aspect. So I'll give this a refresh with my console open. And yeah, that was around 40, so 38. That's going to be the value in which we limit our X scroll to. So I'm going to go down to animate, and we have this clamp right here for the left-hand side of our screen. We're saying we're not going beneath 0, but we also want to clamp things for the right-hand side of the screen. We never want to go above this value we just created of max scroll X. So right here, when we're calculating our horizontal scroll distance, I'm going to wrap everything in a math.min. And I want to say our minimum value should either be what we're calculating already, or it should be our max scroll X. And as long as we wrapped all that correctly, we calculated max scroll X correctly, we go to our game. Now when we go over to the right-hand side, you can see that we're not scrolling past and revealing parts of our scene that don't exist anymore. So that's how we scroll things on the x-axis. I want you to pause the video now and try setting up scrolling on the y-axis by yourself. It's going to be the exact same way we did things on the x-axis, just using y-coordinate values. So see if you can get it done, and let's get started if you're ready. So how might we go about scrolling the y-axis now? Well, like I said, pretty much the same thing for the x-axis. We just need to provide y-axis variables. So we want to copy this right here, paste it down below, and we're not going to be getting the horizontal scroll distance, but rather the vertical scroll distance. And what this is going to represent is on the y-axis from the center of our map, how far is our player's center from this y-axis? How large is this distance right here? This is what we want to calculate. So what might we need in order to get that? Well, we want our player center on the y-axis, and then we want our viewport center on the y-axis as well. So anywhere where we have x, such as max scroll x, we want to replace with y. But this also means that we need to create these new variables. So we have a viewport center y, we have a max scroll y. Let's create those at the top with our other const. So let's create max scroll y. What is that going to be equal to? Well, not our map width, but rather our map height. And in this case, we would need to get a viewport height as well. So neither of these are available just yet, but we can create them. Right beneath where we have map width, I'm going to create map height. And what is this going to be equal to? Well, of course, it's going to be equal to 16. That is our tile size. But the height is dependent on map rows. And we don't have map rows available to us. We will create it up above, replace one instance of calls with rows. And this is also going to be equal to 28, because if we look within MapperMate, this tile set that we're using, or the map that we created in this case, is going to have 28 rows as indicated down below. So we can set that equal to 28, but there was one more constant which we needed to create. We have our map height. We need to create our viewport height as well. So our viewport width is equal to canvas width divided by map scale. I'm going to duplicate that and replace width with height. And this is going to be equal to not our canvas width, but our canvas height, which is set up above. So we're basically just replacing all these values based on our canvas height. And then we're going to need a viewport center, but on the y-axis. And this would be equal to our viewport height, not our width, divided by 2. And we might be good with all these new constants and values that we need down below within our animation loop. Let's see. So we have our vertical scroll distance. We already have player center y. We did that while we were adding our center property. We have our viewport center y. We just created that. And we have our max scroll y. So really, the last thing we need to do here is take our vertical scroll distance and add it within c.translate, but on the y-axis. So instead of translating by 0 for every frame, no matter where we move, we're now going to translate our y value of our entire scene based on this vertical scroll distance. We need to negate this to make sure that it is moving within the correct direction. And that should be all we need to get our map moving on the y-axis. So now, when I start moving downwards, you can see that our map scrolls along with our player, which is awesome. And if we go too far down towards the bottom, we're not actually scrolling things because there is nothing that exists beneath the bottom of our map. Yes, we can still travel off of it, but that is okay. That is just based on how our map is created. My recommendation would be to add some trees around the bottom of your map and then some collision blocks to prevent your player from going off the bottom or something like that. But this is more for getting you a good head start in regards to creating your own Zelda game in the first place. You can see when I move towards the top, I cannot scroll past the top of our screen, nor the right. We have perfect scrolling in place for both our X and our Y axis, and this is going to allow us to just continue our game in a great direction with a great start. So that's how you add horizontal and vertical scrolling to your very own top-down game. So the next thing I want to cover is how to add some sort of sprite animation to our game, specifically for our character, because right now, a blue square is not a great character. We want to bring liveliness to this game, and a great way to do that is to replace a blue square character with some sort of animated sprite. So what we're going to do is this green ninja, this is going to be our player. We're going to pull in a sprite sheet, and we're going to make sure that sprite sheet follows our character around, the blue square right here. And as our player moves in different directions, we're going to get a different animation in place for our green ninja. So how would we go about doing that? Well, the first step is going to be heading on over to MapperMate, because we need some sort of asset to start with for our green ninja. And you'll see, for this specific asset pack, the tile set is by an artist named Pixelboy. I believe I mentioned that already, but if we click into this, we're going to go ahead and be redirected to the Ninja Adventure asset pack, which is great. This is where I got the tile sets from. They're commercially licensed so that we can use them in any project, but we want to get a very specific sprite sheet or image from this asset pack. And to do that, we need to download this whole thing. So if we scroll down a little bit, we're going to see a Download Now button. We're going to click that. And then you can donate to the author, which I always recommend doing because this is an awesome asset pack, of course. But if you just want the asset, you can click no thanks, just take me to the downloads. And we're going to download the Ninja Adventure asset pack. So that's going to download. We're going to open it up. And we want to go inside of the actor folder. And then we want to go inside of the characters folder. And if we start scrolling down, we're going to find a Ninja Green folder. We're going to open that up. And we want to get this file right here, spritesheet.png. So a sprite sheet is basically just one singular image that contains many different states of a particular character or action. So in this sprite sheet, we have a couple of states for our ninja sprite. We have a walking sprite where a character is walking down. We have a walking sprite where a character is walking up. One where they're walking to the left, which you can see right there, as long as I can fix my freaking draw tool. The one walking to the left is going to be this one right here. You can see there's one to the right. There's like little stab animations and so forth. And the reason all these states are in a singular image rather than separate ones is because by putting these within one singular image, we only have to load one image to reference all of our character states. And this image is really small. It's only 5 kilobytes. So we're only making one request. It's a very small request. And it's just going to speed up our game's load time. We don't want massive files being loaded into our game because that is time spent wasted, basically, waiting for the game to load and move around. So that's why sprite sheets exist. Just quickens up our game a bit on the load and allows us to switch between these different states very quickly once we load it into our game. So theory aside, let's grab this sprite sheet. I'm going to do that with Command C, and then I'm going to find our project. I believe I saved that within downloads, and I did. So it is Ninja Adventure, and I want to paste this within our images folder. So I'll do that, and I'm going to rename this. Not sprite sheet, I need something a little more descriptive in this case. I'm going to name this player.png. And if you don't want to go to itch.io to find this sprite sheet, it will be available within the GitHub project in which I'm creating for this tutorial. So that is within images folder that we have there. Now that it's within our images folder, we can use it within our project. So there it is. We see it's within images. How do we begin using this? Well, we want to go over to player.js, and this is how we're going to start. We are going to create a property, and this property is going to be called this.image, and we're going to set it equal to a new image object. So this image object instantiator, I guess you would call it, comes from the JavaScript language by default. And when we're creating a new image, we're creating a new image object, storing it within this.image, And it's basically a JavaScript representation of an HTML image. So any image data that we need to store is going to be stored within this property, and it's going to allow us to render this out on the screen programmatically once we set things up correctly. So we're storing a JavaScript image within this .image. What do we need to do now? Well, this image object has a property associated with it called src, that stands for source. And this is going to look for where our image is located so that we can properly store it within our new image object. So if we were to look within the root of our project for where our new player image is located, where would we go? Well, we would go inside of our images folder right here, and then we would go inside and find player.png. So we're going to take the source and set it equal to this .image.source. And you can see there's our source. We know we're locating the correct thing. All should be well. So this is going to store the image programmatically within this .image, but we can't render anything out just yet. Not until we actually call a canvas draw method within our player draw method that we have right here. So we're going to go inside of the draw method, and we are going to call c.drawImage. So this is a canvas function that takes a couple of arguments, and its whole purpose is to draw an actual image out onto the canvas. It's pretty self-explanatory, honestly. So what can we put for the first argument? We need some sort of programmatic JavaScript image, and we created that up above. So for our first argument, we're going to add this .image. And the second and third argument, the second one is going to be this .x, so this image is x position. And then the third is going to be this .y, the image is y position. And I will say this before we get into the animation portion. These arguments are going to change based on how many arguments we put into c.drawImage. It is confusing, but the second argument and the third argument here aren't actually going to represent the x and y coordinates as we begin to add more arguments. But for now, since we only have 3 arguments, it's totally okay in this case. So c.drawImage with the image we created with an x and a y value referencing where our player is on the screen. Let's save that, and if we did all of this correctly, we should see our image now within our game. So I'll go back to our game, which is right here, and you can see, yeah, our sprite sheet is rendered out kind of correctly. We have our whole image being rendered out, which is what we want to start with. So the next thing we want to do is crop this image so that we can begin looping through its different states. How this is going to work is we are going to crop a very specific portion of our image. We'll start with this one right here. So we're only going to display this one state of our entire sprite sheet. And as our character begins to move, we are going to move this crop location. So you can think of this as a crop box. This crop box is going to move to the next portion of the state. So you can see these 4 segments of our ninja right here represent where our ninja is walking down. We're going to crop this portion first, send our crop box down to the next one, send it down to the next, and then once it reaches the final portion of the walking state, we're going to send the crop box back to the very beginning. So the algorithm here is we crop our image, and then we move the crop box based on where we need it to be in the sprite sheet to produce some sort of animation. So we're going to do exactly that. One thing I do want to note is if your image right here is large and it hasn't fully loaded before c.drawImage is called, you're going to get a JavaScript error. So this is a pretty small image, it's loading quickly, but just in the off chance that your image is larger than the one we're using, you want to make sure that you're only calling c.drawImage if it is fully loaded. So we're going to add a check before we actually crop our image. And to add a check, we can add a this.load property, set it equal to false, and then right after this .image is assigned to a new JavaScript image object, we can call this .image on load, and this is going to be equal to a callback function. So what we're saying is we're setting up a function that's going to fire as soon as our image loads. And we're setting our image down here, but eventually after everything is loaded with our computer, this is what is going to fire, this function right here. And after everything is loaded, we can call this .loaded and set it equal to true. And as long as this property is true, we know we want to call c.drawImage. So before we call any draw code, we're going to do a check that says if this has not loaded, we are going to return from our draw method altogether. So we don't want to call any code unless this loaded is equal to true, which we're only setting equal to true if the image is fully loaded. So just a little safe check right there to prevent any JavaScript errors that you might get if your image is a little bigger than what we're using right here. So let's get to cropping our image. We're going to do that with c.drawImage. It's a little bit of a confusing function, but I'll guide you through it. We're going to create a const called cropbox, and this is going to be equal to an object with an x, a y, a width, and then also a height. And this is going to represent how large should our crop box be and where should it be placed within our sprite sheet. So let's say right now, by default, our crop box is just displaying everything because everything is being rendered out on the screen. Well, we want to shrink our crop box so that is only the size of one segment of our player. And we're going to do that by looking at our sprite sheet within Finder. If we look over here, we can see the dimensions of the sprite sheet are 64 by 112. So 64 pixels wide by 112 high. And by looking at our sprite sheet, we know we have 4 frames going from left to right. 1, 2, 3, 4. So if we take our width here, 64, and divide that by 4, we know the width for one frame should be 16 in this case. We're just dividing this entire width by 4, and that is going to give us the size of this one individual image for the width. So for our crop box width, we're going to change that to 16. And to be honest, we could do the same thing for the height, but I'll just straight up tell you that the sprite sheet is going to be 16 for the height as well. Everything within these sprite sheets are 16 by 16 in regards to dimension. But to start, our x and y can also be 0 because we're rendering out the very first sprite sheet. We don't need to push this to the right. We don't need to push it down. We just want to render out this very first image to start. So 0, 0, 16, 16 for our crop box. Right now we're just storing this within a const, but we need to begin integrating it within c.drawImage. So as I mentioned, this function changes based on how many arguments you use. And if we want to start cropping things, the arguments 2 through 5 are going to be your crop box dimensions. So the first one is going to be where on our image, on the x-axis, should we begin cropping things? We're going to say at a location of 0. The third argument is going to be where on the y-axis should we begin cropping things. We're also going to say 0. We already determined that. And then the fourth argument is going to be how wide should this crop box be? Well, the width of the first image that we have right here. And then the fifth argument is going to be how high should our crop box be? Also going to be 16. That is the height of the crop box. So everything we already determined by setting it equal to our constant crop box, those are going to be our first 4 arguments basically. So the crop box's x position is going to be cropbox.x. The y position is going to be cropbox.y, and then the width is going to be cropbox.width, and then the height is going to be cropbox.height, like so. Off to a good start, but we need 4 more arguments here. And these next 4 arguments are going to be the actual position in which we are drawing this image out on. And the position is just going to be basically what we were using earlier. So this .x for the x coordinate, this .y for the y coordinate, and then we need to determine at what size should we be drawing out this cropped version of our sprite sheet. And we want it to be the exact same size as we declared up above when creating our player. So we are going to reference this .width and then this .height for arguments 8 and 9. It's a big function here with a lot of arguments, very confusing. I wish these had labels and that it was passed through as an object, but what are you going to do? This is what the Canvas API provides us. So if we did all this correctly, we should be cropping based off our crop box dimensions, and we should be moving and drawing out this image based on wherever a player is on their x and y coordinates and at whatever size we declared when instantiating the player. So let's save and go back to our game over here, and you can see now we are cropping just that one very specific portion. So off to an incredible start, but we want to begin animating this now. And I kind of referenced this earlier. To animate this, we want to begin pushing the direction of this crop box. So it looks like the sprites are laid out going downward. So if I want to animate my sprite walking down, we need to push this crop box down on the y-axis to the next image in line. We're going to go to this 4th image and loop it back to the very beginning. So we need to edit the crop box's y coordinate to render out the next part on the screen. How would we go about doing that? Well, this is really what we need to focus on, our cropbox.y. And right now, that is equal to 0. We want to begin multiplying this by a particular frame, and we're going to loop through a certain amount of frames based on the frames available to us within our sprite sheet animation. So looking at our walk down animation, how many frames do we have? Well, we have 1, 2, 3, 4. 4 frames. We want to multiply cropbox.y by this .current frame, and this is going to represent what frame are we currently showing within that sprite sheet. Are we showing the first one right here? Are we showing the second, third, or fourth? That value is always going to oscillate between those numbers, whatever frame we're currently on. And let's say, by default, that current frame is equal to a value of 0. Well, we're just going to get a value of 0 right here when we multiply that by cropbox.y. That is okay, because we know when current frame is equal to 0, we want to render out the very first image within our sprite sheet. But if we change this to something like 1, which would be the next iteration of current frame, and multiply that by y, that would also be 0, because cropbox.y is also equal to 0. What we really want to do is set that value not equal to 0, but equal to 16, because that's how much distance is available from the top of our image right here to the next portion of our sprite sheet. So if we push this down by 16 pixels, we know we're going to render out the very next image within our sprite sheet. So we shouldn't be multiplying this by cropbox.y. That is equal to 0, and we're always going to get a value of 0 in that case, no matter what we multiply with. Instead, we're going to multiply that by our cropbox height, the height of the cropbox. So this is now equal to 16. If current frame is equal to 0, we're going to get a value of 0, render out that first sprite image. But now, if current frame is equal to 1, we times that by 16. This value right here is also going to be 16, which means we would successfully be pushing our cropbox down by 16 pixels in this case, exactly what we want. So that's kind of the idea in regards to how we're going to go between the different images, but we still need a little bit more setup here to get this working correctly. First, we need to create this .current frame as a property. So up within our constructor, I'll say that we want a new property called this .current frame, and we're going to start off at a frame of 0 right here. And that's great. That should render things out, but only for the first frame. We need to start oscillating this value from 0 to 3 and then back to the beginning of 0. And to do that, we're going to go over to update. So if I were to take this .current frame for every frame we're running through within our game and add 1 onto that, this .current frame is just going to shoot up very quickly because our game is running very quickly. And if we see this in action, refresh a couple times, you can see something's moving there, but our sprite just disappears completely. And not really what we want. We do want to limit the rate at which this increases, but we will do that after we actually get this looping back to the beginning. So we're going to a current frame of about 4, 5, and onwards. We don't want that. So a way to get numbers to oscillate, this is a really cool way, by the way, and you can use this for other things besides game development. If we want to oscillate between a number of, let's say, 0 to 3, and then go back to the beginning, here's what we can do. We can set current frame equal to the current frame, so whatever that might be, in this case it is 0, and we want to add 1 onto that. Duh, right? That's pretty much exactly the same thing as what we had before, this .current frame plus plus. So exact same thing right now, but the trick here is if we use a modulo operator and divide that by the amount of frames that we want to go through, the max amount of frames, which in our case would be 4, we are always going to be looping through these values right here, 0 to 3. And if we wanted to increase this number right here, let's say our animation has like 4 or 5 frames. Let's go with just 4 to keep it easy right now. If our animation had 4 frames, we wanted to go through 0 to 4, we just increase this value right here by our max frame plus 1. So in that case, we would change this to 5, and we would get the exact same effect. We would only be looping through numbers 0, 1, 2, 3, and 4, and then we would always go back to the beginning. And I'm going to change this back to 3 because our sprite that we're looping through only has 4 frames, but I want to really get this in your head in regards to how this is working, because it is really cool. So let's say our current frame is 0. Great. We add 1. We're going to render out the second image within our sprite sheet. Now, if we were to modulo that by 4, what does that mean? Well, the modulo says divide by the number 4 and get the remainder. Well, there is no remainder when trying to divide 2 by 4. So in that case, we are just using whatever result we have right here, which would be 2. And we're storing that within current frame, and we go to the very next iteration of our loop. So we go to the bottom, and then we're calling update again. Current frame is equal to 2 in this case, so what happens next? Well, we do 2 plus 1, that is equal to 3. 3 modulo 4 is going to give us a value of 3. We're storing that within current frame. What happens? We go back to the beginning of update. So now we have 3 for current frame, and this is where the fun part comes in. 3 plus 1 is going to give us a value of 4. So 4 divided by 4, well, that's going to give us a value of 0. And if we get a value of 0, we're setting that equal to current frame, only rendering that very first part of the animation. What happens next? Well, if current frame is equal to 0 in this case, we add 1 onto it, we get a value of 1. We just restarted the process in this case. So it's a really cool way to loop between numbers using the modulo operator, especially when the numbers over here are smaller than what you are dividing by with the modulo. Just a cool trick. Hopefully I explained that well enough, but if you ever need to oscillate, this is the way to do it. So if we save this and go back to our game, we're going to see there is animation. It might not look like it. We're just going so fast because our game's monitor is refreshing so quickly that it just looks like it's all blending together. So we have the animation in place. Our frames are looping from one end to the beginning. Next, we want to slow this down because this is a little crazy in this case. And to slow this down, I'm going to add another property right beneath this .current frame. This is going to be called elapsed time. I'll set it equal to 0. And I want to start adding on to this value for every frame in which we call update. So this .elapsed time is going to add on to itself the delta time that we're passing through our update method right here. And if you're unfamiliar with delta time, it is basically the amount of time that has passed in between each frame, and I'm calculating that within index.js over within this animate function right here. You can see the delta time is calculated, and then I am passing it through into player.update. So that is the amount of time that has passed, and if we store it in one large variable, we know the total amount of time that has passed. Delta time values are usually pretty small. They're like 0.1, 0.2, because that's the amount of time in between frames. But we want the total amount of time, and that's why we're storing it right here within this .elapsed time. So the idea here is we only ever want to add 1 onto our current frame like we're doing right now if this .elapsed time is greater than a particular value. In this case, let's say I want to go to the next frame of our animation if 0.1 seconds have passed. Then in this case, I would say if elapsed time is greater than 0.1, that is when I want to add onto our current frame. And that's pretty much all there is to it, almost all there is to it, because we're going to need to reset elapsed time. If this number right here just keeps growing, eventually it's just always going to be greater than 0.1, and we're just going to be calling this like we were previously, just very quickly. We need to make sure that we're always resetting this every time we set this .current frame. And we can do that by saying this .elapsed time, if we are going to the next frame of our animation, we want to subtract from this 0.1, the interval we're checking everything with in the first place. Because let's say elapsed time right here is a value of 0.16. Well, in that case, yes, we would like to go to the next frame of our animation. That's cool. But if we subtract 0.1 from this, that means this .elapsed time at the end is going to be 0.06. So we take that to the next frame of our update method. So we take that to the beginning, and then we're going to add the current amount of time between the frames onto this value of elapsed time. So 0.06 could be increased to a value like 0.2 in this case. And we know that this statement is going to be true down below. We're going to activate the next frame, but allows us to keep in mind any leftover time that might have happened in between frames, because it's not going to be exact that every time we call update that the amount of time that has passed was 0.1 seconds. It might be something greater, so we need to take that into account. And by calling this right here, we're basically resetting elapsed time so that we can continue going through our if statement right here. So just make sure that you are subtracting from elapsed time the value that you're using up above. And then you can save, refresh, and now you can see that is happening at a much slower rate. So if we wanted to slow down our animation, we would change this value right here to something larger. And so we don't have to change this in two spots. Let's make this a const up above. I'm going to say that this is a const of interval to go to next frame. I think that is pretty self-explanatory. And right now that is 0.1. I'll replace these two instances with that new constant. Change it here and there. And now, if we wanted to slow down our animation, we just increase this value. So if I change that to 0.5, you can see every 0.5 seconds we are now changing our animation, which is cool. But we want something that looks a little better. And I think 0.1 is great, honestly. I think that matched the rate on my monitor. I might even slow that down slightly more to 0.15. I think I will keep that right there. I like the way that looks. So right now we are animating by default. I don't really want that to happen. Doesn't really make sense if we're just standing there to be in some sort of walking state. And we know that we're going to need to transition between different states in the first place. We need to walk left, down, up, and right, and all that. So in this case, what I like doing is adding in a property that encapsulates all the sprites that we might want to use, or at least all the states. So I usually name that property this.sprites, and it's going to be equal to an object that contains pretty much all the crop boxes of the sprites that we might want to use. So the first one we're using is walk down. And that is going to be represented by some sort of crop box. And we know the dimensions for that crop box right here that we already created. This crop box right here represents our walk down state. As we can see, we are currently walking down with that crop box. So I'm going to copy the values and paste them within this walk down sprite. And eventually we're going to refactor things right here. Let's do that now. I'm going to have one singular property called this.currentSprite, which always represents what sprite do I currently want to render out on the screen. And by default, we want to render out our walk down sprite. So right here, we are just referencing our walk down sprite, which is a crop box, which we're going to use within c.drawImage. So now that we're using some sort of dynamic property here, we don't need a static one. We don't need this crop box anymore. We can get rid of this. And instead of referencing crop box x, height, width, and height, we can go ahead and reference this.currentSprite values instead. So everywhere within c.drawImage in which we have a crop box value, we're going to replace that with the dynamic crop box in which we have up above. So if we save this, everything should still work exactly the same, and it does, which is great. But by changing this to a dynamic property, what this is going to allow us to do is, based on different states and different actions that our user takes, we can switch over to a different sprite sheet. So what is a different sprite sheet we might want to use? Maybe something like walk up. Now, if we were to include a walk up animation, let's look at our sprite sheet. What would we need to do? Well, right now, our crop box value is right here to start. Walking up is one box over to the right, about 16 pixels, so we would need to shift this over by 16 pixels to start, and then do the exact same thing. Push it down by the height of each frame here until we get to the fourth one, and then we're going to go back to the beginning. So, for walking up, what do we want to do? We want to shift over our crop box by 16 pixels, just like that. And if we were to set our default sprite to walk up in this case instead, now we should see our player trying to walk up instead of down. So with the save and refresh, you can see exactly that. So the whole idea here is we switch our current sprite based on specific actions. And what actions are going to determine whether or not we're walking up or down? Well, when a user presses W or S on their keyboard. And that is determined by a pre-generated method right here called handleInput. So you can see if the key D is pressed, we are setting our player's X velocity equal to a negative X velocity constant, which is declared up above. But we don't really need to mess with velocity. That just determines how quickly our character moves around. If D were pressed, we'd want to change this current sprite equal to our sprites object, but a sprite of walk right. because this is what should happen when we hit the D key. We don't have that set up just yet, but let's add this preemptively for everything. If keys A is pressed, we'd want to change our current sprite crop box equal to walk left. And then if W were pressed, that means we are moving up. We'd want to change this equal to walk up. And then finally, if S is pressed, we'd want to change this equal to walk down. So we have walk up, we have walk down. We need to add walk left and walk right. So I'm going to copy walk up, change that to walk left, and then the same thing for walk right. We do need to change the values here because we know our sprite animation is different for each of these. Walk left is going to be a crop box of 32 pixels over from the far left of our image. So 32 for walk left, and then these increase by 16, so we know preemptively that this is going to be 48 for walk right. But honestly, that's pretty much all there is to it. Because within handle input, we are now changing our current sprite based on which key we are pressing. No matter which direction we move, we should change to the correct sprite sheet. So you'll see if I'm moving to the left, we now have the walk left animation. If I hit right, we now have the walk right animation. If I hit W, we're going up. If I hit S, we are going down, which is awesome. But we don't want to be walking forever. So what I want to do in this case is, if I'm not pressing any keys, I don't want to be looping through the amount of frames that we have for each sprite sheet. I just want to be rendering out the very first frame, which is represented by when this.currentFrame is equal to 0. So we know the idea here. We need to get this.currentFrame equal to 0 when nothing is being pressed. And we can do that within handle input. So we have this if and else if statement block right here, which says if we're pressing any of those keys, we want to change the current sprite. Well, if we're not pressing anything, this else statement is going to fire. And I want to do what? I want to set this.currentSprite.frameCount equal to 1, which means we're only going to render out the very first frame. We're not going to loop through anything else. And you might be a little confused here because I just created this property right here of frame count. We are going to use this in place of this hard-coded value of 4 right here, where we are looping through those interval values of current frame. So when we're going from 0 to 3, that is all dependent on this hard-coded value right here. I'm going to change that so it's a dynamic property. And if I change that, well, this.currentFrame when we're not pressing anything, this is equal to a value of 1. And if that's the case, this.currentFrame is always going to be equal to 1. We're not going to be moving our sprite sheet, no matter which direction our character is facing. And that's cool and all, but I really only declare that property down here. We need to make sure that we are also declaring it within each of our available sprites, because each sprite that we're actually referencing here could have a different frame count. In our case, they all are the same. They are a value of 4, but you never know. Someone might create a sprite sheet that has a walk left animation with 8 frames instead of 4. So it is smart to do this anyways, regardless if all the animations are the same like they are for our case right here. So I'm going to add a frame count of 4 for each of those, and by default, no matter which way we are facing, we are going to be using that and looping through all those frames using this little function right here. But the whole idea is if we're not pressing one of those keys, we're going to set the frame count equal to 1, and that's going to prevent animation from occurring altogether. So let's save this. And then if we refresh, you can see, yeah, pretty much the walking animation only occurs on initial walk, but now we're not really walking at all. We're pretty much only rendering the first frame no matter which way we face, which is on the right track. But in order to fix this, whenever we're pressing down a current key, we need to make sure that we're setting the current sprite frame count back to its original amount. So the walk right frame count was originally 4. We want to set that equal to 4. We want to do this every time we are switching to one of our animated sprite sheets. So for walk left, walk up, walk down, we want to do it for all 4 of those instances. And then when nothing is pressed, that is when we want a frame count of 1. So really, by dynamically changing this value right here, when we're not moving, we're only going to ever get a current frame of 0, meaning don't animate anything. But if we are moving, this is going to loop through 0 to 3 to create that animation effect. So make sure that within handle input, you're changing the frame count accordingly. And with that, I save and refresh. You see now when we're walking, we have the animation in place, no matter which direction we move, which is pretty sick. But if I stop, the animation stops as well, because we're setting that frame count back equal to 1. So that's all there is to it to start. I think the last touch-ups that I'll do here are going within our draw method, and I'm going to comment out that square currently surrounding our player, because that is just some debug code. And then I want to slow our player down a bit. I think they're moving quite quick. I'll go down to something slightly slower, like 175, see how that looks. And I might go down a little slower as well. Let's go down to 150. And you'll notice, if you look really closely, that there's a small black line being rendered out here. Sometimes with Canvas, there is an inconsistency with how pixels are rendered out on the screen. By 0.5 pixels, it's really annoying, but thankfully we can fix this when looping through our animation using c.drawImage by going to our crop boxes, Y value, and adding 0.5 onto that. So all we need to do, we refresh, now you can see that little annoying black thing goes away. And our sprite sheet is looking quite fabulous, honestly. Like, I don't think I could do better than this in this case. So yeah, that is going to be how we add some sprite animation along with movement to our character. And we have that functionality in place where if we stop, our sprite stops animating and so forth. So hope you enjoyed the tutorial, and I'll see you in the next one. So the next thing I would like to cover is what I would call front rendering. So if I were to try to walk behind this building right here, you can see that I'm just automatically placed on top of it. Same for any of the other buildings, we're just walking on top of them, even though our character should be behind them. Now, there are a number of ways to code this. One is by rendering out these buildings as individual objects, and then based on where our player is relative to these objects, we say, how should we order this rendering? Should we be placing the buildings first, or should we be basically rendering out our character first before rendering the buildings? That's one way to do things. But I do think that there is an easier way to do this, and that is by rendering out any tile which should be on top of our player as its own separate layer. So if we look within MapperMate, we're going to have a layer within here called front renders. And as you can see, when I hover over this, we are currently highlighting all the things that should be rendered out on top of our player. So I created a layer specifically for this. And since the last video, I actually edited the map a little bit. If I were to go to the original template, which is right here, actually, you're going to see that I took the guy off the top of the roof. Just because I didn't want to have to create a second front renders layer. I'm just trying to make this as simple as possible. But note, you can have multiple front render layers for what we're about to do. But the whole idea here is we're going to render out this layer separately from everything else on our map. And this one specific front renders layer is going to be placed on top of our player. So it'll make more sense, of course, as we code it, but what would we do first? Well, you're going to be exporting everything within this MapperMate project, including the front renders layer. If you created your own map, then anywhere where you'd want to have tiles rendered on top of your layer, put them within their own separate layer, and then rename that layer to something that's understandable, like front renders with Control R. So once you have all that exported, which you should already, we're going to go over to our project once more, and we're going to look inside this data folder. So here, you can see that I have L front renders, and this contains all the data for the tiles that I want rendered out on top of my player. And we want to begin using this separate from all of our other data that we have exported from MapperMate. So we're going to head back on over to index.js, and we want to focus on some of the pre-generated constants and layer data that MapperMate gave us. And we're going to look at this layers data object. So right now, the layers data object contains all of our maps layers, and we're just rendering all this out onto one singular canvas, and then we're drawing out that canvas over and over again. That is how we're getting this background that we see within our game separate from our player. Everything that you see panning, along with our player moving, that is all exported by MapperMate, and it's just a canvas object that's being rendered out over and over again. But the thing we want to do different is we want to take out our front renders from this layers data object. So we have this property right here. I want to take this out because I want it rendered separately from our main canvas. I'm going to take that out right here. And then I'm going to create a new constant right beneath this, and it's going to be called front renders layer. And I guess we can make that plural layers data. And we'll set this equal to an object, and then I'm going to paste in that front renders layer in which I cut out from the layers data object up above. So we want to render this out separately. How would we do that? Well, let's find out where layers data is kind of being rendered out and placed on a canvas. If I am to search for this, we're going to find out that this occurs within the function render static layers. So when we call this function, we're creating an off-screen canvas. This is just an HTML canvas element, but we're never actually rendering it out within our browser. This is just rendered out separately, and then we call c.drawImage to render that out within our browser. We're creating an off-screen context, which allows us to access all of the canvases, different functions, and methods. And then we're looping through each property within our layers data object. And then we're loading in whatever images we need, and we're rendering everything out directly onto the canvas using this method right here. So this works for the layers data object, which we have scaffolded for us up above. But we just took out this property right here and placed it within a new const called front renders layers data. I kind of want to do the same thing, which we're doing right here within render static layers. I want to create an off-screen canvas, I want to create an off-screen context, and then I want to draw all my layer data out on top of this off-screen canvas. But I only want to do that not for layers data, but our front render layers data. I want to do that separately. And as a result, we need to make this function dynamic. So we're no longer going to hard code in here the layers data. We're actually going to pass through an argument, and I think this argument, it makes sense to also call this layers data. And if we call this layers data, we don't need to change this right here because we know that layers data, this argument needs to go inside of here so that we can loop over all the properties and then render them out on our off-screen context. So we're making this dynamic, but if we make this dynamic, we need to change the original location in which this is being called. So if I do Command D, I'm going to find another instance of that exact name. And render static layers is being called for me on line 193 within start rendering. This is also scaffolded for you by MapRoommate, and what's going on here is we're just calling this function, and we're storing all the layer data within a const of background canvas. That's perfect. And up above within our animation loop, you can see that is being called with c.drawImage. So we draw out our background canvas, and then we draw out our player on top of that canvas. And the whole idea here is we're taking out our front render layers and we're going to draw them after we draw out our player. It's going to make sure that all those are drawn on top of our player and that our player looks like they're behind all the front layers. So let's get back on track here. We have render static layers. We just made this dynamic and we need to pass through some argument here. And the argument contains layers data. And for our background canvas, we want to use that original layers data object. This references this up above. But now I want to create a new canvas to be rendered out on top of everything within our game. And I want that to contain the front render layers data object. So we need to go back down to where we just stored new canvas data inside of a canvas. And I'm going to create a new canvas called not background canvas, but front renders canvas. I think that makes sense. And I want to call render static layers, but not with the layers data, but rather the front render layers data, in which we just created within this lesson. So you'll see that I didn't declare this as a const or a let because I actually want to use this within animate without having to pass it through as an argument. And if that's the case, right above animate, I can create a let called, what did I call this? Front renders canvas. And that'll be undefined to start. But as soon as we call start rendering, which is done right here when we load this file, we're going to initialize the front renders canvas by calling render static layers with our front renders layer data. So what this is going to do is it's going to store an HTML canvas within this let right here. If I were to console log this out, save it, and then try to visit our game with the console open, we should see an HTML element being logged out, and there it is. So like I said, this is an off-screen canvas. Nothing here within this canvas is actually rendered out onto our browser. This canvas right here is completely separate from the JavaScript one in which we're creating. And that's honestly good for performance purposes. We don't need to render this out until we're absolutely ready. And how do we render this out? Well, within our animation loop, where we're drawing out our background canvas, and then we're drawing our player, right after that, we can call c.drawImage on our main HTML canvas. Remember, C references our canvas context, and that is what is actually being rendered out here on the screen. If I were to inspect this, the canvas right here has a context in which I named C for speed purposes. That's a whole nother story why I named it C, but yeah, let's get to this. We want to draw what on top of our player, not the background canvas, but the front renders canvas in which we just initialized down below when we call start rendering. So we have this function, which we are calling right here on file load. What happens when we call this function? Well, we initialize our canvases, and then we call animate, which then goes up above, and we run everything within this animation loop. And then we're going to render out our scene by first drawing our background canvas, then drawing our player, and then we are going to draw our front renders canvas. So everything that should be layered on top of our player. And with that, if we save, refresh, and we did all of this correctly, you'll see when I start to move around, this is our real player right here, and I go behind something like this little guy right here that we are actually placed behind it, and we're rendering out our front renders canvas on top of our player. But our back renderings all look great, nothing needed to change there. But now we have this really cool effect that actually looks like our player is part of the game. You can see I can go behind this building right here. That guy that I originally exported our game with, yeah, he's still showing there. I'll show you how to get rid of him real quick, just in case you have an instance in which you want to get rid of some data on your map that's already here. One thing you could do is you could go to Mappermate and just run a fully new export, but that might be a little overkill. A better way to do this, in my opinion, is we'll find the offending map. I think I made a copy right here, which we're referencing. Yeah, this one had the guy on top of it. And you'll see if I hover over some of these layers, we can see exactly what we're dealing with here. So I have this characters layer, and when I hover over this, we have the guy showing. And I now want to get rid of the guy here. What I can do is I can go over to my characters layer right here, and I can kind of deduct, just by looking at this array, which of these values represents the character in which I'm looking at within Mappermate, just based on position. You'll see anything that is not a 0 represents a particular character. So we have one like 7, we have one, a symbol of 1, and then 3. And we can see, just based on the characters within this layer, those are all near each other. This one's going to be 7, this one's 3, this one's 1. So if I wanted to get rid of that guy right there, I can just change this 3 to 0. And when I save like this, everything's changing because I have Prettier running. Just an auto formatter for JavaScript. Don't need to worry about that too much. But once I refresh, you're going to notice that the guy is gone like I originally intended to do. We still have a bottle right there. I'm going to get rid of that. And yeah, that's going to be right here within house decorations. So same deal. I'm just going to go over my layers, find house decorations. And the bottle might be one of these. I might need to look a little closer to see exactly what is within house decorations. And I'm going to assume it says 1284 right here. So I'm going to change that to 0. Refresh, and you'll see that the bottle is gone. So I got that right just by kind of judging the position of how that array looked to my map over within Mappermate. But if you did want to include the guy and the bottle there, well, I guess I'll show you that too. Why not? So we would want to add a layer, and this is going to be a second front rendering layer, because in this case we should have two things being rendered out on top of our player. First, the building background, and then the man and the bottle. And these are going to be two separate layers because the characters tile set doesn't actually have the decorations within it. But if this is the case, then I would just place the man on this new layer. I would rename this layer front renders 2, and then I would want to create another layer because this layer needs a different tile set, and I believe that jug was somewhere within the decorations, and yeah, here it is right here. I'll zoom in on that. Here is the jug. I wanted that on top too, but this needs to be a front render layer, so I'm going to name this front renders 3. And now we have two more layers in which we can have their data exported and then placed within Mappermate. Ideally, I'm going to add a right click to export data directly from each layer within JavaScript, but I don't have that right now. So what you'd want to do is just export a new top-down game. We would open this up, and then we're going to have the data automatically exported for this. So you'll see we have front renders 2 and 3 now. We would want to grab those 2 files and then put them within our current game. So I'm going to do exactly that. I'm just going to go over to Ninja Adventure. I already copied those 2 files, and now I can press Command V, and those are available to me within my game. Now I just need to integrate them. So here they are, and I'm going to go over to index.js, and what I need to do is just add those 2 files as new properties right here within front render's layer data. So I'm going to copy and paste this current property. I know that I should have a 2, and then I should also have a 3 for what I'm referencing right here. So we're just creating some property syntax. What these reference are going to be these files. But honestly, these files aren't going to be available to us until we actually import them into index.html. You'll see here that we have a const of L front renders 2, a const of L front renders 3, and we're trying to reference those, but they're not actually available because we never imported them within index.html, because usually this is generated for us automatically with MapRemate, but since we're kind of changing things as we go, we would want to import these manually. So I'm going to find our front renders, and there it is. I'm going to paste that exact same script tag and then pull in front renders 2 and front renders 3. So once again, we are just referencing these files. We're pulling them into our game, and we are almost done. We have front renders 2 and 3, but we also need some tile set associated with each of these new layers. So you'll see right here, we had front renders generated for us automatically. I'm actually going to copy and paste this twice like we did up above. Make sure I'm referencing front renders 2 and front renders 3. But I know that each of these layers has a different tile set. So I just want to go back to MapRemate real quick and see exactly what tile sets I'm referencing. So for front renders 2, I'm referencing the characters tile set. If I were to look at my characters layer, we can see that is available to us with this image URL right here. So for front renders 2, I would change the image URL portion to make sure that I'm referencing my characters tile set. And that's just going to make sure that I'm pinpointing the exact character that I want within this tile set, rather than some random tile that's available to us in another tile set. Just making sure we're referencing the correct ones. And I want to do the same thing for front renders 3, which is going to have that jug. I already know that is within the decorations tile set. We don't need to change anything there. But as long as we did all this correctly, we should see these 2 additional front renders being rendered out onto our screen now that they are within front renders layers data and that we have tile sets associated with them. So let's save index.js, go back to our game, refresh, and there's our character and the jug. Perfect. And if I walk behind them, you can see that they are rendered on top of us. So yeah, that is just a cool, quick little lesson on front renders and getting objects rendered in front of our character rather than walking over them. I really think that this is the easiest method, even if you have a larger map, to get things rendered out on top, because it can get a little complicated with organizing objects and rendering everything out dynamically and sorting and all that. But yeah, this is a more than viable way to get those objects rendered out on top. So the next thing I want to cover is how to add enemies to our game. We chose the locations in which we want these enemies spawned at, but we don't have any JavaScript objects to actually represent an enemy. We need to create a JavaScript object and then assign the necessary properties to it to get these enemies moving around. And then we're going to add a pathfinding algorithm, which I think is pretty cool, to randomly determine where these enemies will move to, but within a specific boundary. So the first thing we need to do is get some sort of enemy sprite sheet imported into our game. And if we look at the Ninja Adventure asset pack, which we originally downloaded for this project, we are going to have enemies inside of this actor folder. And if we go inside of monsters, we're going to have a whole assortment of different enemies in which we can use. All the sprite sheets are provided for us, which is absolutely awesome. But there are 2 enemies in specific I want to use for this tutorial. No exact reason, I just thought they looked cool. And the first enemy is going to be Bamboo. We can see this is a green bamboo kind of guy, which is going to be walking around all cool like. And then we have a dragon, in which I also thought just looked cool. It contrasts well with the background with the green colors. So these are the 2 sprite sheets I want to use. in this case, I want to copy this dragon sprite sheet and then open up a new Finder window, go into our original project, which is Ninja Adventure, and then go inside of images and paste in that sprite sheet. Now this is a very generic name. I always recommend being as specific as possible, and obviously this is the dragon sprite sheet. So I'm just going to call that dragon.png for now. And we also had the bamboo sprite sheet. So I want to copy the bamboo sprite sheet, and paste that within our images folder. And same deal, we don't want to call this sprite sheet, but rather bamboo, like so. So as long as we put those in the correct spot, over within our game, if we look within our images folder, we should see those files now, which is great. So we have dragon and we have bamboo.png. So the next step is going to be creating some sort of monster class, and I'm going to make this a generic monster class in case I want to create different kinds of enemies like we're about to do. I could create a class for bamboo, I could create a class for dragon, but I think that these two classes are going to share a lot of properties in this case. So it makes more sense to create one generic class rather than two separate ones. And then if we really need to separate things, we can do that later on. But I think in this case, it's okay to do one generic monster class. So if that's the case, I want to create a new file, and I'm going to save this file as no other than monster.js. And this is going to be a class, so I'm going to put it within our classes folder. We'll save that. And now what should go inside of monster.js? Well, I think player.js is a great starting point. We have things like position, width, height, velocity, a center, images, sprites, everything we need to get something animated onto our screen, and moving around is already here within our player class, which means this is a great start for us to begin using and creating a monster class. So I'm going to copy everything within player.js and paste it within monster.js. Now we do need to edit a few things here. One, we no longer need these two constants up at the top because these are really x and y velocities meant for player movement. When we have some sort of input with our keys, we are affecting our player's velocity with these two values, but monsters aren't going to be controllable by the player. So that means we don't need these two constants, but if we get rid of those two constants, we need to find out where they are being used within this class. And right now, that is within handle input. And that is the only location. And like I said, monsters, we're not going to be handling any input with them, so we can pretty much just get rid of the handle input method altogether for monster.js, and that's putting us in a great position, but we're not done just yet. We also need to change the class name. So this isn't a player, but rather a monster. And we can keep this image source the same as player for now. We just want something rendered out on the screen to start with the monster class. So what would I do next to begin rendering out monsters? Well, we need to make sure that this new file that we created, monster.js, is actually pulled in to index.html right here. So to pull this in, it's pretty straightforward. We just need to duplicate a script tag. In this case, I'm going to duplicate classes/player.js, and then swap out player.js for monster.js. And now this should be imported into our game, and we should be able to use it within index.js. So how would we begin creating some sort of sprite that we have rendered out on our screen using monster.js? Well, very similar to how we're rendering out and creating our player right here on line 141 for me. What I'm going to do is I'm going to create a const called monsters, and this is going to be equal to an array because I know within my game I want multiple monsters, not just one. It's okay to create just one player up above because we only have one player within our game, but for the monsters, we need multiple. And if you need multiple monsters, it pretty much always makes sense to put these instantiated monsters within an array. And I'm going to show you how to render all these out at the same time using this array. But let's create just one monster to start within this array. How do we do that? Well, we would create a new monster. This references the monster class, which we just created. And what kind of arguments are we using for a monster? Well, arguments that are very similar to our player class because we just duplicated our player class. We didn't actually change anything regarding the arguments. And if that's the case, we can take the object within our player instantiation and use that as our object within our monster instantiation. So we're saying spawn a monster on the exact same spot as our player right now. I don't really think that makes sense. So I'm going to change our x coordinate to 200, and I want my monster shifted down a bit on the y-axis. So I'm going to increase y to 150. So now we should have a monster object within this monster's array. But we need to make sure that we're looping over every monster's object within this array and then calling that monster's update and then draw method. Because remember, our player class has draw and update, and so does our monster class, as you can see right here. So we need to update our monster's position based on the time that we're passing through and any other logic that we want to add for our monster movement. And then we want to render our monster out on the canvas, which we do with this draw method. So that's going to be the next step, is calling update and draw for every monster object within our monsters array. And to do that, we're going to go into our function of animate. Now I need to think to myself, where within our layer hierarchy do I want to draw out our monsters? Well, first we're drawing our background canvas. Great. Next we're drawing our player. Okay, well, do we want the player rendered in front or behind of our monsters? I think it's going to vary later on, and maybe we'll revisit this because a player might be in front of a monster, but we render out our player behind them depending on where we're calling player draw or monster draw. So this is something we'll come back to in regards to monsters and players, but I do know for a fact that I want our monsters drawn behind our front renders, just like our player, because it wouldn't make sense for a monster to move on top of a building randomly. We want to show them behind those parts of the buildings, which they shouldn't be on top of. So after we call player draw, this is where I'm going to render out our monsters. And how do I render out our monsters? Well, I could call monsters dot for each, loop through all the monsters, and then call their draw and update methods. But monsters might be removed from the monsters array dynamically. And if you ever have some sort of object being removed from an array dynamically, especially within a game that is calling animate over and over again, like we are right now, I pretty much always recommend looping through the back of an array. Because if we were to splice out a monster from our monsters array, and that one monster exists in the front of the array, well, we're effectively changing the length of our array. We're basically shifting everything back by one index. And there is the opportunity for a flash to occur within your monsters of how we render everything out, because we are moving everything dynamically right after we spliced something out of the monsters array. We're not going to get into that too much, but just know if you're ever removing something real time from some sort of large array, especially within a game, loop through the back of an array, because otherwise you might be dealing with some sort of flash whenever you are actually removing enemies. We don't want to do that. So to loop through the back of an array, we're going to use a traditional for loop. And the first part of this for loop, we're going to create a let of I, and I is going to be equal to our monster's array length minus 1. And then for the second part of this for loop, we're going to say keep looping for as long as I is greater than or equal to 0. And then we know we're starting at the back of an array, so we're going to subtract 1 from I for every iteration in which we go through this for loop. So we are looping through the back, but now we need to select one specific monster within this array that we're looping over. So I'm going to create a const, name it monster. And how would I grab just one specific monster? Well, I would select our monsters array, and then I would use I to reference the index of the monster we are currently looping over for this for loop iteration. And that's all we need to do. And now that we have that one monster object selected, we can call things like update and then draw on top of it. So now what does a monster.update method take? We can always look within monster.js to find out. We have a delta time, which is going to be used for animation purposes and also for updating our horizontal and vertical positions. And then we have collision blocks, which are going to be used for if our enemy collides with one of the collisions blocks we placed within MapperMate. So we need to make sure that we're passing these through absolutely, and we can just do that by passing through the delta time, which is calculated up above within the beginning of the animate function, and then passed through the collision blocks, which are also generated for us automatically with MapperMate up above right here. So we're passing those through, And now we need to pass through one more thing for monster.draw. What is that argument? It is going to be our canvas context, because that is what we're using to draw out an actual image for this monster class. At least we will be doing that. So within monster.draw, we pass through the context, and now we should see our monster being drawn out at this specific location, 200 by 150. So let's go to our game, refresh, and you can see here is our monster in this case. So we're using the same sprite that we're using for our player, and that is okay to start. But of course we want to swap this out with something more dynamic. And we don't want our sprite facing up by default. Let's just fix that right off the bat. Let's get our sprite facing towards us. We set our default sprite equal to walk up. I actually want it equal to walk down in this case. These sprite sheets are going to use kind of the same positions anyways for every single sprite sheet. Besides the point, but yeah, now you can see that the monster in this case, is facing down. That's fine, but like I said, it's time to swap out our image right here. And to swap out our image, I'm going to get rid of this hard-coded value and replace it with one that is dynamic. And I'm going to call this image src, stands for image source. And since I'm trying to make this dynamic, I need to make sure that I'm adding this as an argument within our constructor. So there it is, but now I need to make sure that I'm actually passing this through for every monster that I create. And I know I'm creating monsters within index.js right here. So I'll add in that property, image source, and specify as a string what image do I want to reference for this monster. Well, first I want to go inside of my images folder, and we'll start off with bamboo.png. So now we're using a completely different sprite sheet, and if I save that and refresh, you can see now we're rendering out our bamboo monster, which is pretty awesome. Let's render out another monster. To do that, we're just going to duplicate what we have right here for new monster. But we're going to change the X and Y position, so I'll move this to the right of our current monster, and then I want to use a different sprite sheet. I want to use dragon.png. And all these are formatted the same way as I mentioned, so we don't need to change much in regards to the actual crop box locations in which we have within our sprites object. All we need to change in this case is going to be our image source. So I'll change bamboo equal to dragon.png, refresh, and now we have two monsters being rendered out on our screen, which is really freaking awesome. Now, in the chance that you are using sprite sheets that don't follow the same format, you'll see right now for dragon and also for bamboo and also our player, these are pretty much all formatted the same way, where the first column and the first 4 rows are all our walking down sprite animation. But let's say that you have some sort of sprite sheet that doesn't follow this format. What you would want to do in this case is make sure that your sprites object right here is also dynamic. So we wouldn't have these static sprites because our bamboo sprite sheet might be different from our dragon sprite sheet. And if that's the case, well, we need to make sure that we're passing these through dynamically. Let's go ahead and do that real quick. Everything's going to function exactly the same, but I want to show you how we might be changing this dynamically for your project rather than exactly what we're doing right here. So I want to make this .sprites dynamic. I'm going to cut out this current object that we have assigned to it and replace it with a sprites argument. And we need to create that sprites argument. So right here, I'll add sprites, looking good. But now we don't know if walk down is going to be available to us. We have no idea in this case. It's going to be passed through dynamically. So rather than just trying to guess and hard code a value right here, I want to reference the very first sprite within our sprites object. And to do that, I can wrap this .sprites in object.values. So object.values is something that JavaScript provides by default. And what that does is it pretty much changes some sort of object with a bunch of different keys and properties into an array. What this allows us to do is access the very first property within this .sprites using an array format, an index right here, which we're going to do by saying we want to access the very first element with a 0 index. So that's what object values allows us to do. If we didn't have object.values, well, this would be an object. This really wouldn't work for grabbing that very first value. So we're going to grab the very first sprite within this .sprites, but now that we made that dynamic, we need to add a new sprites property here for each monster. So I'm going to paste in the object in which I cut out previously, and you can see that this is really bloating up our object instantiation right here. And we know that our bamboo and dragon sprites are going to share the same kind of sprite locations and the same kind of states. They all have a walk down, a walk up, a walk left, and a walk right state. And if we want these two to share these states, well, we could either duplicate this sprites property and paste it down below within the other monster, the dragon monster, or we could assign these to a const and reuse them. So I'm going to do exactly that. And I'm going to say that this is the monster sprites. So this entire object represents all of our monster sprites. So now when I'm actually instantiating new monsters in this case, I don't need to assign that giant object multiple times. Now I can just assign monster sprites right here. It's much cleaner, much more understandable. And we could even move all these sprites to a different file if things started getting a little too unwieldy. So with that, everything should still function exactly as before, because now we're passing this through within a property argument, and that is going inside of monsters.js to be used here, and here where we're selecting the very first sprite, which is going to be walk down in this case. So let's save that, refresh, and these are animating just like before. But what this gives you the opportunity to do is create a new sprite, maybe for just the dragon sprite, and then you can alter all these values right here to match up with whatever sprite sheet that you're using. So that's kind of why we just did that, is in case one of your sprites has different values, now you know how to change these values dynamically for one of those sprites. So the next thing I want to cover is movement for these sprites. And it's a little complicated. We're going to need to know a little bit of math, but it is nothing that we can't handle. So how does the movement algorithm work for these sprites? We are going to focus on our bamboo guy right here. The idea is we want to create some sort of circle around our enemy. And within the circle, we are going to select a random point on the circle's radius. So let's say randomly, we select this point right here. We want to get our enemy moving to that point. And then after something like 3 seconds have passed, we're going to select a new point on the circle. So that point might be over here. And even though our enemy might be right about here after 3 seconds has passed, we told them, well, we want you to go somewhere else. Change your direction completely and start heading back down in this direction. That's basically the generic idea for this algorithm, is we create a circle, a radius around our enemy, and then we select a random point and we change our enemy's direction to go towards that point. And as long as we always base one of these points right here off the center of our enemy's original position, they are never really going to go outside of this boundary right here. So we don't have to worry about them going somewhere crazy within our map, like in someone's home or in their backyard or trees or something like that. So that's basically the generic idea here, is we want to create this kind of boundary for our enemies and then start pushing them in a very specific direction, which we will select on the circle's outer perimeter. So I want to select a new location about every 3 seconds. I think that is a good interval, but we can always fine tune that as needed. So to begin setting this up, we're going to go over to monster.js. And right beneath update, I'm going to create a new method. This is going to be called setVelocity, because the velocity values right here for x and y are actually what determine what direction our enemy is moving in and how fast is it moving in that direction. So that is the main value in which we want to change in this case. So I want to call whatever is inside of setVelocity every 3 seconds. How would I do that? Well, very similarly to how we did it above for our animation. After a specific amount of time has passed, we want to call whatever is within an if statement. So I'm going to create an if statement that says if this dot elapsed movement time is greater than some specific value, 3 in this case, that would mean 3 seconds, then I want to call all this following code. I'm going to console log out, call movement code in this case. So this .elapsed movement time isn't something that we actually have just yet. And the reason I'm not using this elapsed time variable in which we created up above is because this is elapsed time specifically related to our animation function, and it's always being reset based on when we go to the next frame of our animation. This .elapsed time is never going to be greater than 3 because it's being changed so often, because every frame we are subtracting a specific interval from its actual value. So if that's the case, I want to create a new property, and I'm going to name that property elapsed movement time, because that is the time associated with when our enemy should be changing its movement. So I'll say that this .elapsed movement time by default is going to be equal to 0. And as time begins to go on, I want to take this and make sure that I'm adding on to it the delta time associated with our game. Now, if I want to use our delta time, I need to pass it through as an argument for set velocity, and then I need to make sure that set velocity is being called whenever we are calling update. So right after we're doing all of our animation functions and all that, I'm going to call this dot set velocity, and then I'm going to pass through our game's delta time, which is coming through our update method right here. If we want to be really specific on what's going on here, this is going to say randomly choose place for enemy to move to. That's basically what set velocity is in this case. So we're passing through the delta time, we're adding on to elapsed time, whatever amount of time has passed in between frames, and then if the amount of time that has passed is greater than 3, we are calling this const log. But we always want to be resetting this .elapsed time because this is something that should happen continuously. And to reset this .elapsed movement time, we can take the property, this .elapsed movement time, and subtract from it the interval in which we want this code to be called by. And we are saying we want it to be called every 3 seconds. So we just subtract 3, and then we're going to get accurate values for if we have any discrepancies, like how much larger is this .elapsed movement time than 3? Is it 0.15 seconds larger? Okay, whatever. We're subtracting 3. Now we have 0.15 seconds for the next call already added to it. And one quick thing before we actually test this out is I'm referencing elapsed time here. That's stupid of me. I just created elapsed movement time. Let's make sure that we're actually adding on to that and not what is being used for the animation. So as long as we did all this correctly, we should save, open up our console over here. And now if we refresh, we should see that console log every 3 seconds. And there it is. The reason we're seeing it being logged out twice is simply because we have 2 enemies in this case, so we're just calling them consecutively. And that's okay, maybe we'll change that up later on, but this is what we want to start. We want to be able to call code every 3 seconds to change our enemy's direction every 3 seconds. Okay, so now we are going to determine what velocities to set for our enemies. Now, how would we go about doing that? This is where the math comes in. So we are going to start with some sort of circle around our enemy. And the first thing we need to do is get some random angle on the circle in radians. So let's say that our first line starts here. We're going to find a random angle. Could be this large, or this large, or this large, or this large. We want to get that angle because that's going to help us determine the actual velocities in which we need to start sending our player in a particular direction, like up this way. So how do we get this angle right here? And how would we make sure that this is random? Well, to get some sort of random angle, we can create a const called angle and set it equal to math.random. Math.random always returns a value 0 to 1 randomly. It can be 0.5, 0.55, 0, 1, etc. And we're going to use that by multiplying math.pi. That is a value of 3.14, repeating whatever number math.pi is because it goes on forever. And then we want to multiply that by 2. So this is going to give us a value of around 6.8 when we multiply math.pi by 2. And we're basically getting any random value, 0 to 6.28. Why 6.28? What does that even represent? Well, this is the value of a circle within radians. So a quick little lesson on radians for those of you new to it, because I know it was confusing for me when I was first learning about it. We typically, at least within the US, I don't know wherever else does it, we think of circles using degrees. So this right here would be 90 degrees, this would be 180, this would be 270, and this would be 360 degrees. But within the realm of math, it's pretty common to always use a value of radians. And 1 radian is about this large, I believe. It's something like 35 to 55 degrees large. But yeah, this is what 1 radian is equal to. And a radian is when this outer arc right here, if we were to stretch that and basically flatten it out into a straight line, the length of this is equal to the radius of the circle. So you can see that this flattened out arc right here is pretty close to the radius of the circle we have right here. That would be 1 radian in this case. And now if we were to extend our angle so that it actually reached the complete opposite side over here, we would typically say this is 180 degrees, but this large arc on the outside right here is actually equal to 3.14 radians. So our radius times 3.14, and that is equal to math pi. We double that value. Let's say we extend our angle all the way to the beginning. Right here, we're just overlapping that. Now we have pi times 2 radians. So 3.14 times 2 is going to give us 6.28. We now have a full 360 degrees, but in radians, which is equal to 6.28. So when you think of radians, just remember it is when this arc right here is equal to the radius of our circle. But really the main values we want to focus on are 3.14 pi and then pi times 2, 6.28, which is exactly what we're dealing with over here when we are choosing a random angle. So any value 0 to 6.28 is what we're getting with our constant angle. So that's great, but now we need some actual coordinates. So we got the angle, cool. How do we get the coordinate of this point right here? How do we get that? Well, we're going to be using some math functions called sine and cosine. So we're going to start off with math.cosine. And you've probably heard of this function if you've taken some math classes. We have a cosine function, and what this cosine function does is it takes a value of an angle in radians. So let's say that we have 1 radian right here. We're going to plug that in, and what is cosine going to give us? It is going to give us the length of the right triangle created from this angle. So this angle is creating a right triangle, and a right triangle is a triangle that has a 90-degree value right here. So we're getting this angle. We know this is a right triangle, and it's going to give us this x distance associated with the right triangle. So from here all the way to where the right triangle ends, it's giving us this x distance. Because if we go up from this x distance, what are we going to get? Well, the point in which we're trying to move our player to in the first place. So when we call cosine, it's only ever going to give us a value of -1 to 1. Why is that? Well, this x distance right here, if we go all the way to the right side, let's say x reaches the end right here, that is the length of our right triangle. X is going to be 1 in that case. But let's say a right triangle is actually in the opposite direction. We start from the center, we go towards the left. Well, how long is this new x distance? Let's get rid of the old one right here. How long is this new x distance given we still have a circle there? In this case, it is going to be equal to -1. So really, cosine is only ever going to give us one of these values, -1 to 1, depending on the x distance created by the right triangle of wherever we are placing this point. So the right triangle is going to change depending on wherever our point is. So based off our angle, we're going to put it inside this cosine function, and that's going to give us our x distance, which we're going to be using for our enemy's velocity, at least on the x-axis. So that's going to be the first thing we need to do, is kind of create a const for a target location. Where is our enemy going to go after we call set velocity? Well, we need an x and then a y value in this case, but of course these aren't going to be equal to 0. We want to start off at the enemy's original position. So I'm going to call this dot original position specifically for the x coordinate. Now we never actually created this property. We need to do so. So right beneath where we have this dot x and y being set, I'm going to say that this dot original position is equal to an x and a y. And the original position is going to be the original x and the original y in which we're passing through. This right here is never going to be edited. So we know that this is going to stay true. Although x and y might be edited, original position x and y, these are never going to change. So we know those are always going to be in one spot, which means that we can use them correctly within set velocity. So to determine the target location, we have the original position, and on top of this, we're going to add math.cosine. Remember, that returns a value -1 to 1, but it accepts an angle as an argument. We're going to choose the random angle in which we generated up above. And that's going to give us basically how fast our enemy should be going on the x-axis so that we can start pushing our enemy in that direction. But we do need to multiply this by a larger value because math.cosine, it only returns a value of -1 to 1. Those are very small values. Imagine if we assigned our enemy to have a velocity on the x-axis of something like 1. We're not even really going to be seeing them move at all because that is such a small value. We need something larger, something like 20 in this case. The higher this value, the faster our enemy is going to move, and basically the further out the target location is going to be from our original position. So we're saying we want the radius of our circle to be a bit farther out in this case by multiplying our angle right here by 20. And we can even be good coders in this case by creating a const called circle radius and setting that equal to 20. And then right here, instead of using some sort of static value, yeah, circle radius is static, but at least we know what 20 represents in this case. So we're getting the target location where we want to move for our x-coordinate, but we need to do the same thing for y. So we got the x distance right here, but the next thing we need to get is going to be this, and that is the y distance. So how would we get the y distance right here? Well, we want to take that same angle, which we're just saying in this case is 1, and we want to put the angle inside of a sine function. So we put 1 inside of there, and sine is going to return to us this y value. It is also going to be a value of -1 to 1, but it's going to be representative of where this point is and how large this angle is. And based on the ratios of the values produced by sine and cosine, we are going to get the exact point on the perimeter of our circle in which we want to start moving our enemy. So that's kind of how this works right here using sine and cosine. We're getting that target location, which we just saw right there with the green. So we want to mimic what we're doing right here for x. I'm going to copy that value, paste it in for y, and rather than reference our original x position, I want to reference our y, and we know whenever we're getting that right triangle's y distance, we want to use sine in this case. It takes an angle, just like cosine, but this right here, the x and y, we are getting the perfect ratio between x and y to deliver our enemy to the target location in which we would like them to go. So this will give us our target location in this case. So if I were to redraw that circle right here, we're saying that our target location is right here. We are getting that perfectly, the exact pixel value in which we want to send our enemy to. But as our enemy begins moving towards that direction, let's say our enemy is this blue dot right here. Yes, they are moving towards it, but our location could change. We could get a desired target location over here. And if that's the case, well, we need to get the direction associated with our monster's new location right here, and then get the x and y velocities associated with the right triangle created between these two instead. But everything should always be based off of the original position in which we are setting our monsters. That way they don't travel outside of the circle to some random crazy location on our map. So we want to make sure that we're getting the change in distance, or the change in direction, however you want to call it, between our enemy and wherever our new target location is on the map. So a lot of developers, they will call this dx delta x. I'll just be a little more specific. What is the change in x between the target location and the enemy's current position? We can get that by referencing the target location in which we just created on the x-axis and subtracting from it the enemy's x position. We want to do the same thing for y right here, and this is always going to get the x and the y values, the change in location for the x and the y. So bringing this back up, what is the change in location between this red point over here and then this blue point? Well, we are getting that by taking the target location's x value and subtracting from it our enemy's x value, so however long this is, and then we're doing the same thing for the y-axis. We're just getting the distance of these two lines right here. That's what we're storing right here within delta x and delta y. And this are going to give us things in which we could use to calculate our enemies' velocities, but they could be very big values. Like let's say delta x is something like 40 and delta y is something like 20. These have the ability to change and vary a lot. We want to make sure that we're never setting these values to something that is ridiculous, otherwise our enemies are going to be traveling at warp speed. As a result, we want to normalize the delta x and delta y. These represent the direction we want our enemy to go, so we're going to normalize it, which just means set these values to a ratio from -1 to 1, very similar to like what math cosine and sine produces. We're going to be doing the same thing manually. So to transform these values right here to values of -1 to 1, here's what we can do. The first thing is we need to get our right triangle's hypotenuse. So we can say that the hypotenuse distance is equal to math dot square root. And to get the hypotenuse, we need to square our change on the x-axis. So we'll multiply that by itself. And then we need to add on to this the change on the y-axis and multiply that by itself as well. That's going to give us the hypotenuse, and sorry I didn't describe this, the hypotenuse of a right triangle. So let me draw that out real quick. We have a circle over here. We have a right triangle from here to here. The hypotenuse of a right triangle is going to be the distance of the longest side of the triangle. So the distance of this line right here that I'm highlighting in green, that is the hypotenuse. That is what we're storing right here within a constant hypotenuse. And to normalize our delta x, we can call this normalized delta x. What we're going to do is take the delta x and then divide by it the hypotenuse. Because we know the hypotenuse is always going to be greater than the distance on the x-axis between those 2 points. It just always is going to be greater, so we're always going to get some sort of ratio value from like -1 to 1. And we want to do the same thing for y. So I'm changing normalized delta x to y right here. I'm going to change delta x to delta y and divide that by the hypotenuse. And now we have normalized values. So this is going to give us something like, I don't know, 0.6. And this one will give us something like 0.4 in this case. And these normalized values, what they represent are the velocities in which we want to send our enemies in. So what we can do is take our velocity property on the x-axis and set it equal to our normalized delta x and do the same thing for y. Now these values might be a little too small still because we're getting very small values 0 to 1. But if that's the case, we can multiply these by something greater, like 20. And it's going to make sure that our enemies are moving at a very consistent rate, no matter where their new target location is going to be. So let's see if we did everything correct there. I'm going to refresh. And now every 3 seconds, we should see these guys begin to move. And it should always be a consistent rate. And they're never going to go outside the radius of their original circle. So right now that radius is 20. We are using that radius right here. And also when selecting a target location, we can always shrink this if we would like to something like 15 to make sure that they don't travel too far. We'll replace these values of 20 right here with circle radius. Save, refresh, and now they should only move in an even smaller portion right there. It's kind of something you would just want to test. You could even draw some debug code by drawing out a circle using that radius from the original location, but I think this is okay to start. So we see that our enemies are trying to go to new locations based on their boundaries, and sometimes when they hit collision blocks, they just kind of get stuck. But I think it makes more sense for when an enemy hits a collision block that we reverse their velocity altogether. And I think that'll create a lot more natural of a movement for these enemies. So I know that the collision detection for enemies and collision blocks is happening within check for horizontal collisions and check for vertical collisions. So what we're going to do is whenever an enemy collides with a collision block, which is happening within all the if statements, within these functions, I want to take the x velocity, so this .velocity.x, and then reverse it to create some sort of bounce effect. So I want to change the x velocity when we're checking for horizontal collisions in both spots where our enemy might collide, whether or not they're going left or right. And then for vertical collisions, if we collide with something, then I want to change the y velocity, reverse that, in both locations, whether or not we're going up or down. Now we don't want to set our y velocity equal to 0 if we collide with something on the y-axis. Doesn't really make sense in this case. So I'm going to delete those two locations where y velocity is equal to 0. Those were pre-generated for us. And if we save, go back to our game, refresh, now when our enemies begin to move and they hit a collision block, they should reverse their velocity on that axis. And they do, which looks awesome. So that one just bounced, but we're always choosing new coordinates for these enemies to go to, but never outside of their boundary, which is absolutely awesome. This is looking great. I'm very happy with how this looks. So I want to make sure that these enemies are moving by default and that there's a bit of delay in regards to when they change directions. So in order to get these enemies moving by default, we need to revisit set velocity. Right now, we're only calling this code which determines the random velocity every 3 seconds. So what we could do is say we want to fire this from the get-go by saying, or if this elapsed movement time is equal to 0, then we also want to call this code. But in order for this to be equal to 0, it needs to happen on the very first initialization. And you can see right up above, we're adding delta time for every time we call set velocity. We need to move this to the end of the if statement to make sure that elapsed movement time can be equal to 0 in this case. So refresh, and now you can see that those are moving automatically, and every 3 seconds they should change their direction. You can always lessen that value by just changing these 3's right here. We could say const change direction interval is equal to 2 instead of 3. And then in these two locations in which we have that value of 3, we'll replace it with the change direction interval. And that's just going to determine how often should our enemies actually change their direction. So it's going to decrease that amount. Now every 2 seconds we should see it. We can even do something like 1, save and refresh. And yeah, now those are going to change quite often. I kind of like 1, honestly, so I think I'll keep that for now. But really the last thing I want to show for this movement tutorial is how to place your enemies in exact positions. Because right now they're next to us, which is cool. And we're going to keep them next to us for the time being, but I do want some enemies placed down here, but I don't know how to get those coordinates, at least easily. To get those enemy coordinates, we can go over to MapperMate and simply hover over the location in which we'd like these enemies to be spawned. And you can see down here on the bottom left, I am providing the exact mouse coordinates in which we would need to spawn these enemies. So if I wanted to spawn a bamboo starting in this exact location, what are the coordinates? Well, it's going to be an x of 48 and a y of 400. So let's create a bamboo right there. I'll go to index.js, and then within my monsters array, create a new monster referencing bamboo.png. And what were the coordinates? Well, it was going to be 48 by 400. So for x, put 48. For y, put 400. And now when I save and refresh, we should see a bamboo enemy in that bottom left-hand corner. So I will go down there, and there he is moving around with our movement code perfect in place. Whenever it collides with something, it's just going to bounce off. Love the way that is looking. Let's add the rest of our enemies. How would I do that? Well, same deal. I'm just going to hover over the location I want to put an enemy, and then go back to our monsters array. So I'll create 3 new monsters, and I know 2 of these are going to be dragons. So for our first dragon, I want an x of 112 and a y of 416. So 112, 416. For our next bamboo, I want 288 by 416. So 288 by 416. And that was actually 516, 416. There we go. And then for our last dragon, I want 400 by 400. Nice and even. And now all those are going to be spawned in their exact spot with minimal effort, which is great. So I'm going to go down there, and hopefully they actually are spawned down there in the right spots. And it seems like they are. They're all going around the original location. And you can see that imaginary boundary that we created with the radius in place and how often they're changing direction, which is based off that interval we created. So eventually we will get rid of the rendered sprites that are there that don't matter anymore. But for creating enemies in the first place and then getting them moving based on some sort of algorithm, I think this is a great first step. So with our enemies moving around and such, the next thing I want to teach you is how to add some sort of attack animation so that eventually we can attack and get rid of these enemies. But the first step is going to be, how do we get some sort of attack animation on screen in the first place? We're only going to focus on our character for this lesson. So first, we need some sort of weapon. Where can we get a weapon? Well, if we search within our Finder for our Ninja Adventure Asset Pack, and we go inside of Items, there's going to be a Weapons folder. We want to go in there, and there are a lot of different weapons we can use here. This is a really great asset pack. Can't keep saying that enough. So really take your pick, but the weapon I want to choose for this tutorial is going to be the lance. You'll see what this looks like right here. It's just a simple little lance pokey thingy. And I'm going to use the version of Sprite in hand because I want this to only appear when my character has an attack animation running. So this is when the lance is within our player's hand. So I'm going to copy this with Command C, and then I'm going to go back to our project. We named that Ninja Adventure, of course. I'll go inside of Images, and then I'm going to paste that in. Now we always want this to be descriptive, and Sprite in hand is not descriptive of what the image represents. This is actually a lance in this case. So I'm going to rename it to lance. Now once we rename things, we should see it within our project folder of images, which there it is. It's really small, but yeah, it's there. We can begin using it. So the first thing I want to do is get a lance rendered out on top of our character. And I want the lance to follow us around because, of course, it's our player's lance. It should follow wherever we go. So to begin rendering this out, I'm going to go over to player.js. And whenever we have some sort of image imported into our game, like a JPEG, a PNG, such as lance.png, what do we want to do? Well, we want to create a new JavaScript image object, just like we did for our player originally. So right beneath the properties of this .image for our player class within the constructor, I'm going to create a little comment here that says lance, or we can say player weapon, something descriptive here, just to indicate what we're about to create. And the property is going to be called weapon sprite. Now, what should a weapon sprite be equal to? Well, I just said it should be a new JavaScript image object, and we're going to set that with new image. Remember, this comes with the JavaScript language by default, and it represents an HTML image, but programmatically. So to load something into this HTML JavaScript image object, we can call this .weapon sprite, what we just declared up above, and set its source property equal to the location of the image we want to load. So the image I want to load is, of course, within my images folder, and I want to load in lance.png. Now, it's always safe whenever you load any kind of JavaScript image like this that you have some sort of onload function. So I would want to make sure that I'm calling weaponsprite.onload, which takes a callback function. So whenever our image fully loads, we're going to call whatever is within this callback function right here. And this is a safe spot to set some sort of Boolean, like we did originally with our player. When we set this.loaded equal to true, it just makes sure that we're only ever calling something like c.drawImage for this one particular image if it is fully loaded. So we're going to do that as well, just for good coding practices and make sure that our game is as functional as possible later on for everyone who's playing it. And we're going to say that this .weapon sprite has loaded currently is equal to false. But after it has loaded within this callback function, we will set weapon sprite has loaded equal to true. Now, this is worthless unless we actually begin to use it somewhere within our code, and we want to use it within our draw method. So right now we are saying if our player image has not loaded, then we're returning. We're not actually calling c.drawImage. We also want to do the same thing for that new property we just created up above. Weapon sprite has loaded. So within draw, if the weapon sprite has not loaded, so we're going to say weapon sprite has loaded. If it is not loaded, it's indicated with the bang operator here. Then we are going to return from the draw method altogether. We're not going to follow or call any code that comes right after this if statement. We're not going to call c.drawImage and the additional code in which we're about to write. We're just canceling out altogether. But make sure that you're connecting these two with an OR operator like so, or else things will probably just break, because that's not valid syntax without the OR operator here. So now we have a way to use this property we just created correctly. Weapon sprite is loaded. We're never going to actually draw our weapon unless it has. And to begin drawing our weapon, right beneath c.drawImage, where we're drawing out our player, now we're going to draw out our weapon. Duh. Okay, so pretty self-explanatory here, but to draw our weapon, we're going to follow the same syntax as we have up above. And to make things quick, really, we can copy what we have because we're going to be using a lot of the same arguments here. So I'm going to copy our player c.drawImage and paste it out down below this comment right here for a weapon. So I don't want to draw our player image, but rather our weapon sprite. That is what we created up above within our constructor, and we made sure that it had a valid JavaScript image object. Mixing up my words here. But yeah, we are calling draw on this sprite in which we loaded, and we need to change a few things up right here within c.drawImage. So this is one image. It is not a sprite sheet. We do not need to crop it in this case. And if we do not need to crop an image, well, we don't need the 9 arguments that we have right now. We only need 5 arguments. So I'm going to get rid of arguments 2 through 2 through 5. And I only want to see our weapon sprite, X, Y, width, and height. And this is going to get rid of cropping altogether from this function right here. But what we're keeping is, where are we drawing the image on the X and the Y axis? And how large are we going to draw this image out with width and height? Those are the things we want to keep, because if we recall looking at weapon sprite, it is only one image. It is not a sprite sheet. So if we did all of this correctly, we can save, go back to our game, and now we're going to see that our image is being rendered out, although it is the width of our character and also the height of our character, and that's why it's all stretched out right now. It doesn't really look good because it's not the natural width of the image. If we need to find out what the natural width of the image is, we can go back over to Finder, make sure that we have the image selected, and then we can see right here the dimensions are 6 by 16. So that is the width and height in which we actually want to use right here for c.drawImage. We don't want to draw it out our character width and height because we're going to get that stretch effect. Instead, we're going to use a value of 6 to represent the actual natural image width, and then same thing for height. We're going to use 16, which represents the actual natural image height. Sorry guys, I cannot speak right now, but I'm going to keep rolling with the punches here. Let's save this, refresh, and yeah, that is just looking so much better. But the cool thing is, since we are using X and Y coordinates right here, these are always updated based on wherever a player moves on the screen. So if I begin moving, you're going to see that the lance follows us. We're off to a great start. That is step 1 towards getting some sort of attack animation into our game. The next thing I would do is make sure that the lance is rotated and placed in the correct direction based on which way our player is moving, because you can see it's just always facing down. Eventually, we're going to need to make sure that it goes to the right, maybe the left, or up, depending on which way we're moving and which way we are attacking. So we need to rotate our spear somehow. How would we do that? Well, let's go back to our code over here. We're going to start out by wrapping c.drawImage in a c.save and a c.restore, because we're about to use some global canvas methods. And remember, whenever you use a global canvas method like translate or rotate, it's going to affect your whole canvas unless you wrap it within save and restore. So I want to use c.translate to rotate my image. And why do I want to do that? Well, it is a little complicated within Canvas. Within Canvas, there is no exact way to actually rotate one specific object. Like, we can't grab this weapon sprite and then call rotate on top of it. That would be really nice, but it is just not something that is capable with the Canvas API. We couldn't do something like c.rotate on the weapon sprite and rotate it X amount of degrees. It's just not possible. So we need to do a little bit of a workaround based on what Canvas provides to us. And the way to do this is by translating our canvas. So let's focus on that. What happens with translating a canvas? Well, our canvas expands the entire width and height of our visible area right here. And wherever we translate our canvas to, we're basically transferring that renderable area to wherever we translated our canvas. And the idea here is we want to move our canvas from this normal location to the very top left-hand corner of our image. Because what's really happening is after we translate things, we are going to call rotate, another global canvas method. And that doesn't rotate an object, it rotates the entire canvas. So really, if I were to call rotate on this translated canvas, we would get something that looks a little like this. And you're going to have to excuse my drawing here. It's being done with a trackpad. But say I rotated my canvas by like 45 degrees. Ignore the original one. Our canvas would look something like this. And as we rotate our canvas, everything else that is being rotated with it within the save and restore is also going to rotate, including our lance right here. So as we rotate our canvas, this one thing being rendered out on top of it, the lance, is going to rotate with it. And the reason we are translating our canvas in the first place to the beginning of where our lance is rendered out right there is because imagine if we rotated our canvas from this location. Well, really, what would happen is our lance here would be rotated based on its relation to the top left-hand corner of wherever the canvas is. So we would really be moving it in a circle based on the top left-hand corner. But if we move the top left-hand corner to the top left-hand corner of our lance and begin rotating it, then we're going to get something that is a little more in line with our actual rotation values. One last thing I should mention here is we're going to render out our lance right here. When we render it out, we're actually going to translate it so that its center is exactly at the top left-hand corner of our translated canvas. And if we render it out right here, then we're going to get perfect rotation, as if we were to rotate our lance from its very center. So it is a little confusing with Canvas. Hopefully that explanation helps a little bit. But of course, it'll always make a little more sense with the code as we go about it. So just keep that in mind. The first thing we need to do is translate our canvas to the top left-hand corner of our lance. So we're going from here to you know where, right here. How do we do that? Well, let's head back to our code. We have c.translate ready already. So where is the top left-hand corner of our lance currently? Well, the answer is right here for us. This .x and this .y. That is where we are going to translate to. And by doing that, we have achieved the step of moving our canvas down here. But things aren't going to look great after we do this, because if we refresh, well, now our lance is missing. Because now we are drawing our lance relative to where we just translated our canvas. So if we were to translate our canvas here and then say based on this x and y coordinate, which is now 0, 0 by the way, from this exact location, if I want to draw my lance out at a coordinate of this .x and this .y, like you see right here, well, that means we're actually drawing out our lance somewhere down here, because it's all relative from this new location of the translated canvas. As a result, we want to draw our lance out at a value of 0, 0, and it should be drawn right about here where we want it. So let's go back to c.drawImage and swap out this .x and this .y with 0. We save that, refresh, now our lance is where we want it to be. Everything looks the same, but we're on the right track. This is what we need to do to begin rotating things. So the next thing I want to do is right after c.translate is call another global canvas method called c.rotate. And this takes a value of radians anywhere from 0 to math pi times 2. And that is the full arc of a circle once we do that. So if I were to say I want this flipped, I want it pointing the other way, I would rotate it by math.pi in this case. And if we save that, refresh, now you can see it is facing the other way, but it is not rotated based on the center of the lance. In order to make sure that it's rotated based off the center, I mentioned this a little earlier, we want to make sure that we are drawing the lance directly within the center of the newly translated canvas's top left corner. And if that is the case, what we can do is say we want to change the x and y values where we're rendering out this actual lance image. If we want it to be drawn out directly in the center, we can give a negative value of half the width and a negative value of half the height. So we're saying actually render this out -3 pixels to the left and -8 pixels from the top. And if we do that, we're going to make sure that our canvas is rotated and our image is drawn based on if we were rotating our lance from its very center. So let's save that, refresh. And now you can see that is a little closer to actually just turning the lance from its previous position. I'm going to change that back to its original value, which is 0, or math pi times 2, pretty much equal to the same thing in this case. And once I refresh, you can see that we're actually rotating from the very center of our lance now right here. So let's refresh. And you can see it looks a little off, but really it is just the actual dimensions of the image. We have a big portion right here, which are kind of throwing things off, but I can promise you in this case, things are being rotated the way we want them to be. So on the right track. But now we want to make sure that this rotation value is correct based on which way we are facing. Because right now it's static. If we say that we want to rotate our canvas by math pi times 2, it is always going to be facing down in its original direction. So what we can do is change this value dynamically based on which way we are facing. Now I don't have an exact way to track which way we're facing just yet, so I'm going to add in a property within our constructor. So this is within the constructor here. And this property is going to be called facing. Which way are we currently facing? Well, I actually want, by default, our player to be facing down. And you can see right here, we're using the walk up sprite by default. Let's change that to walk down. And now I need to make sure that this value here of this dot facing changes based on which way we are moving. And we know which way we are moving within handle input. If the key of D is pressed, well then I could say that this dot facing is equal to right in this case, because that's what the D key does. It moves us to the right. Now I want to do this for every key that we have. So if the A key is pressed, facing is going to be equal to left, and then same thing for W. When the W key is pressed, we're going to be facing up. And then when the S key is pressed, we are going to be facing down in this case. So now we have a way to track which way our character is facing. And based off of this direction, we're going to change this rotation value right here. So right above drawing out our weapon, I'm going to use a switch case statement that switches out this new facing property with multiple cases. If our case is, let's start with down, because I believe that is the way the lance is facing. Yep. If our case is down, then what do I want to do? Well, I want to set some sort of angle equal to the value of 0 or math pi times 2. 0 and math pi times 2 are going to be facing down by default regardless. But I don't have this angle available to us just yet. I haven't created this let or const. So up above, I'm going to make this a let because I know I want it to change later on, and say that this angle by default is going to be equal to 0. And based on the different cases, I'm going to change that angle. So when we're facing down, we don't really need to change much, but when we're facing up, in this case, we want to use the opposite angle of radians, and that is going to be math pi. Let's do the same thing for right and left. So when we are facing the right, I believe this should be math pi divided by 2. I might be wrong in this case. The value might be math pi times 3 divided by 2. But yeah, it's going to be one of the two in which we're dealing with here. But I'm going to add in another case and say that this is the one that should be math pi times 3 divided by 2. And really, if you don't know what these values mean, if we have a circle, we're going to have an angle starting about right here, and that's going to be 0. If we use math pi, it means that the radian amount extends all the way to the other side right here. Math pi divided by 2 is a 90-degree angle, and then math pi times 3 divided by 2 is going to give us this 270-degree angle right there. So these are just kind of shortcuts for getting the angles which we want to deal with for rotating our lance. So now that we have these angles being determined based on which way we are facing, we can use them within c.rotate. So I'm going to rotate by this dynamic angle, refresh, and now when I begin moving down, things stay down. That's great. When I move up with W, you can see it's facing up. When I move to the right, yeah, it's facing to the left, I get it. But when I move to the left, it's facing to the right. So we just need to swap out these values for left and right. And I will do that very quickly. Cut, paste, save. And now when I'm facing the right, the lance faces the correct direction. Same with the left. Everything's looking really good. But I do want to make sure that our lance has some offset associated with it, because Obviously, these aren't the correct locations for the x and y coordinates. We want to make sure that the spear is near our player's hand. So to add some offset, right above our switch statement, I'm going to add a let of x offset. By default, it'll be equal to 0, and you can probably guess we're going to add a y offset as well. And based on which way we're facing, we're going to move the lance. So let's set our x offset equal to, when we're facing down, probably something like 8 pixels. Our y offset will be something like 20 because we need to move it quite a bit down in that case. Let's start with just this. Now if we want to use these offsets, that is where we need to translate our canvas to. So we would simply just add on to this .x, our x offset, and then same for our y offset. We can save that. Go back to our game, and that's right in the center of our player, which maybe that's where we want it to be. But I do know that the lance sprite is actually a little off to the left, so we want to move it somewhere over here in this case. And if that's the case, we just need to subtract from our x offset, maybe something like 6. Go back to our game, refresh, and that's pretty close. I'm going to keep things as is. For facing down. Now when we're facing up, I want to keep the x offset the same, but I do want to change the y offset. So I'm simply copying these two values here, pasting them within up. X can remain the same, but y offset needs to be maybe a negative value in this case. Let's try -4 and see what that looks like. So now when we face up, I'm going to say that's probably okay for now. When we switch to an actual attack sprite, we'll fine-tune this, but we're looking good in this case. I think that's okay. Now we need to take care of right and left. Obviously these look atrocious right now. So let's say that our x offset for right is going to be a negative value. Let's try -4. And then we really need to push this y offset down a bit. You'll see we have a lot of room right here. We need to get it right in front of our player's hand. So I'm going to push it down by about 20 pixels in this case. Refresh. And, man, I'm doing this for the left case. I'm going to move everything over there. Now when I'm facing the left, yeah, looks like this 20 y offset is just way too much. Let's have that to 10. I'd say that's looking pretty good right now. We'll fine tune it once we go to our attack sprite. And really we just need to take care of the case of right. So I'm going to copy these two, paste it up to right. Our y offset will remain the same. I want this on the same level, but our y offset, we definitely need more in this case. So I'll try 14, see what that looks like. Definitely going to need more. Let's try 24. A little less, 20. And yeah, that looks good. So now we have a lance that changes direction no matter on where our player is going or facing. So off to a great start, but really we only want to show this lance if our player has initiated an attack. So how might the actual user initiate an attack? Usually there is some sort of button. On a PlayStation remote, it would be something like X. On a keyboard, like we're dealing with now, it's probably going to be spacebar. So let's initiate an attack with a spacebar. Over within our JS folder right here, we have a file called event listeners. And right here, we are listening for events of key down. Now we can add an additional case to say, in case a user presses down on their keyboard and the key is a space. So you can see that I'm adding an actual space right here. That is what we want. We want to listen for a space character. What do we want to have happen? Well, we want to grab our player and call an attack method on top of it. So this attack method doesn't exist within player.js yet, but we're about to create it. So right above draw, I'll add in a method called attack. And what do we want to have happen when we call attack? Well, the idea here is I'm going to create a boolean called this.isAttacking. And it's going to be equal to true whenever we call attack. But by default, within our constructor, this is going to be equal to false. So whenever we call attack, we're simply setting it equal to true. And what we can do with this is only draw out our weapon if we are currently attacking with that boolean we just created. So if this.isAttacking is equal to true, that's where we're going to call all the code in which we just wrote to render out our lance in the correct direction. So I'm going to save and then go back to our game, refresh, and you can see that our lance disappeared. that is great because this that is attacking is equal to false by default. But if I hit space, we set that equal to true, and it's going to exist for as long as our game runs. Now, one quick thing here is you'll see when I hit space that my browser is actually scrolling down. That is a default action associated with hitting the space bar, and we don't want that within our game because space should only make our lance come out. And if we want to prevent the default action within some sort of event listener like key down, when we are calling player.attack, right above that, we can reference the event argument coming through our event listener with event, and then call prevent default on top of it. And when you do that, that is going to prevent the default action from taking place of scrolling our browser down. So we can save, refresh. Now you'll see when I hit space, it's not scrolling down anymore. Perfect in this case. But really, we want to make sure that our lance disappears after X amount of time, maybe like 0.3 seconds. We make sure that we go back to our normal state. So to do that, we're going to go back to player.js, go to our constructor, and right beneath this.isAttacking, we're going to add in an attack timer. And by default, this is going to be equal to 0. So the idea here is when we initiate an attack, we're going to start adding on to this attack timer. And after X amount of time has been added onto this, after X amount of time has passed, then that is when we're going to switch this.isAttacking back equal to false, which in return is going to make sure that we're not rendering out our lance code anymore. So over an update, I'm going to write right beneath if delta time, I'm going to add a comment that says update attack timer. And here's what we're going to do. We're going to grab that attack timer. We're going to add onto it the delta time. But we're only ever going to add onto this if a certain condition is true. And that is if we are currently attacking, if the user has hit the spacebar. So if we're attacking, we're going to start adding on to our attack timer. That's when time should start building up that we can track when we should go back to our idle state or our walking state. So if we're attacking and this .attack timer is less than our attack interval, which would be something like 0.3. That is when we want to add on to things. And then I'm going to add an else if that says, if we are attacking, so we're still in the attack state right now, and attack timer is actually greater than or equal to that interval. What do we want to have happen in this case? Well, we are going to take this.isAttacking and set it back equal to false. We're also going to take our attack timer and set it equal to 0. So as soon as we initiate an attack, we are going to start adding on to our attack timer. And we're only going to be adding on to this if our attack timer is less than a time of 0.3 seconds. Else, if we are still attacking and this timer has passed that time of 0.3 seconds, we're going to say no longer render out the attack state and set attack timer back equal to 0 so that we can run this code again if a user initiates another attack. The only thing I would really do here to clean things up is declare a const called time to complete attack, and that is what's going to be equal to 0.3, so if we ever come back to this code later, we know what we're looking at when dealing with 0.3. So let's save, go back to our game, refresh. Now when I hit spacebar, after 0.3 seconds, you can see that we are reverting back to our idle state. So looking really, really good right here. Love how this is looking. Now I think I just want to make sure that we are going to the correct sprite, an attack sprite in this case. If we look over within our player.png sprite sheet right here, you can kind of see if we go 1, 2, 3, 4, 5 rows down, this 5th row right here is actually representative of our attack sprites. So that's what we're going to use when we begin an attack. And if we want to add those sprites into our player.js file, well, we need to go up to this.sprites object in which we created for walking. But we're going to do not walking sprites, but rather attack sprites. So I'm going to copy this first value right here of walk down, paste it, and rename it attack down. Now these values aren't going to be the exact same. One right off the bat that we can change is frame count. We know this is a 1-frame animation, so I'm going to change frame count to 1. Width and height are the same. We're using the same sprite sheet. Our x is also going to be 0, because if we look over here, when we're attacking down, it's on the very first column in this case. So X will be 0, but Y is going to be pushed down from the top here. And we are down about 64 pixels because each frame is worth 16 pixels. If we go down from the top by 16, 32, 48, 64, we're rendering out the fifth row as desired. So attack down, not for X, but rather Y, is going to be 64. And we want to test out that all these values are correct by default. And to test things out, we can simply change the current sprite equal to this new sprite we just created. So I'm going to change our current sprite equal to attack down. And let's go back to our game, see how it looks. And yeah, we're not really seeing anything just yet. So let's focus on our draw code for our player. We can see that our crop box right here should move down on the y-axis by this code. And it's dependent on height and current frame, but one thing it is not dependent on is going to be our y value. We need to make sure we're taking this y value into account. We didn't need to do so prior because all of our y values were equal to 0, but now that we have a y offset by default, we need to make sure that we're adding this on to our crop box so that we're cropping out that one specific area right here. So to do that, right here for our y crop, I'm going to grab this .current sprite, get the y value, which you just added, and then I'm going to add that onto everything else which determines the location of our y-axis crop box. So save that, refresh, and now we are within the attack state. Looking good. So we want to do the same thing for attacking to the right, left, and up. And this can be done pretty quickly, I would say. So within our sprite sheet, the next sprite is going to be not attack down, but rather attack up. And to move our crop box over one to the right, we need to change the X offset by 16 pixels. So we do that, test out that all of our coordinates are correct by changing this to attack up. Now by default, we're attacking up. We do have some pretty weird black squares going on here, and that is because the sprite sheet we're using isn't perfect, unfortunately. And if we want to fix that, we can just simply change the height of these attack crop boxes to 15. So we change that to 15. Now we got rid of that. We're expanding our character down a bit. That should be fine in this case, at least to get rid of some of that extra black space in which we were looking at right there. So we finished attack up. Let's finish attack left. And then also right. I want to say left is the next one. Let's just change X to 32. And then attack right, we're going to say that our X is equal to 48 in this case. So all we're doing is we're moving the crop box over to those other locations. And yeah, you could see attack left is going to have the crop box X value at 32, and attacking right is going to move that crop box over to 48. So I did actually get those right. We can test things out by changing our current sprite equal to attack left or attack right. Looking great in this case. So I know all those are right, but by default, I want our state to be walk down. Looking good, but now when I go to this attack state, I want to change our current sprite based on which way we are facing. So where do we have attack? It's going to be right here. And when we call this method, now I can run another switch case based on which way we are facing. And I know we're calling that down below when we're determining where to place our lance. So I want to copy the switch case statement, and I'm going to paste it up above within our attack method. And this is just a quick way so I don't have to rewrite the whole entire switch case statement by hand. And I can get rid of all the angle and X offset setting in which we are doing within the cases. So in case of facing down when we attack, I want to change this .current sprite equal to this .sprites.attack down. And I'm going to do the same thing in every single direction. So when we're facing up, I want to change to the attack up sprite. When we're facing to the right, I'm going to change to attack right. When we're facing the left, changing to attack left. And that's pretty much all we need to do when attacking to actually change the direction. So now when I'm facing the right, we go over to that attack sprite, left, up, down. But you can see after the attack animation finishes, we still remain in the actual attack state. So a quick way to do this is to copy the switch case and then add in one more method. And this is going to be called switch back to idle state. We're going to paste in that switch case. And whenever we call this, by default, we're just going to switch back to our walking state sprites. So we want to change every instance of attack in this case to walk for this new switch case statement we just wrote within switch back to idle states. Now we're going to use this when we actually switch back to our idle state, which is happening within our update method right here. We switch back to our idle state within this else if. Write a comment that says switch back to idle state. What do we want to do in this case? In addition to setting is attacking to false and this attack timer equal to 0, we want to call this switch back to idle state. So now based on which direction our player is facing, we're going to switch back to one of those idle sprites of walking. So we'll save, refresh, and now you can see we're going back to the state depending on which way we are facing. So really, last thing we need to do here is just make sure that our sprites are placed in the correct position for the lance, because you can see it is a little off in this case. So let's just do that really quickly. It's going to take a little bit of trial and error, and that's going to occur with where we are drawing out our weapon in this case. So when we're facing down, I think I need to move this down on the y-axis by maybe 4 pixels. Just go back and forth. That is a little too much. Maybe 22 is a good one. I like how that looks. I think I might move it over to the left by 1 pixel with 5. And I think that is good for attacking down. Let's do attacking up. Definitely want to move that to the left by a little bit. So I'll go over to 5. And then I think it should be a little further up. So I'll add -6 in this case. So now when we attack up, I can still see a little bit of a hand. It's kind of hard to see, but I'm trying to be a perfectionist here. Let's move X offset to 4. And then subtract by 7. Yeah, I really like how that looks instead. So up looks good. Let's go to the right. I need to move that down by a little bit. So I'll move the Y offset by adding on 2 pixels. I think I need to move it to the right by 2 pixels as well. And I might need to move it back up by 1 pixel. So that looks good for the right. And now on the left, I didn't actually test the left. Yeah, I need to move that down by a little bit. So maybe by 2. And then over to the left by a lot. Let's try -12. And yeah, that's too much for the X offset. We'll go to 10. Still too much. We'll go to 8. And that looks good for facing the left. So now zooming out and moving around, we have an attack animation in place. But you might have noticed that there was a little bit of a flash right there when I went to an attack animation after walking. And that is because our current frame within update, right about here, this is what determines what frame we're on within our walk animation. Our current frame could be something equal to like 3. And if our current frame is equal to 3 and we try calling out c.drawImage right here, where we're rendering out our player and we change all these values right here, well, we might be drawing out something within our sprite sheet that doesn't exist or that doesn't make sense. So really, whenever we call attack in this case and we switch over to one of those new attack sprites, we also want to make sure that we are setting this .current frame, not current sprite, but current frame back equal to 0 to make sure we don't get any weird flashes occurring when we switch to that new state. So let's refresh, start walking around, and add some attacks there. And it seems to be pretty darn good for what we're trying to do in this case. So looking pretty good overall, but one last thing I want to do here is prevent our player from moving if we have an attack going. It's a little cheap to be able to move our weapon around, I think, while it's out. And I think it's a little more fair to just stop our player movement altogether. It also switches us back to the walk sprite mid-animation, which is kind of weird. So we want to prevent movement altogether if our player is attacking. And to do that, we can go on over to handle input and say, right at the very top, or at least near the top, that if this is attacking, if our player is attacking, we don't want to allow any of the following code to occur, which is actually what pushes our player in a particular direction. That is all we need in this case. So by adding this conditional right there, now when we begin to move and attack, we can only begin moving again once the attack animation is actually over. So looking absolutely great for adding in that attack animation. Next up, we're going to interact with our enemies and make sure that the enemies interact with us so that when they hit us, we begin losing health and they begin losing health as well. So next up, I want to add some interaction between our actual attack animation and when we hit an enemy. Of course, when we hit an enemy, we want something to occur, and that can either be removing the enemy from the game, decreasing their health, or so forth. The idea or plan is really ours in the end. So I think to start, what I'm going to do is when I hit an enemy, I want to remove them from the screen, but eventually we'll build on top of that so that our enemy has health, and we can hit them 3 times before we remove them from the screen. How would we go about doing that? Well, the idea behind this is going to be we want something in which I would call an attack box. So an attack box is just some sort of box that follows our character. And in this case, I'm going to say this red box is my player's attack box. You can kind of see it represents the width and the location in which our player is actually attacking. It's pretty close at least. Maybe it's somewhere like right there instead. But the reason I want to make an attack box is so that we have some sort of way to detect collision between where our player is attacking and where an enemy is on the screen. So the easiest way to detect for a collision between 2 objects is with rectangular to rectangular collision detection. I believe that's the way to do it. So we're going to have a box around one of our enemies, and we're also going to have a box around our weapon. And we're going to detect for collision between the two. So if our enemy box right here collides with our weapon box, what's going to happen? Well, we're going to say we want to remove the enemy from the game. So that's the gist of what we're doing here, is we're going to create a box that represents where our weapon is at all times, and based on that box's coordinates, width and height, we are going to detect for collision between that box and a box around one of our enemies. So how do we begin creating this so-called attack box? Well, we are going to go over to player.js, and I'm going to create a new property within our constructor. And this is going to be called no other than attack box. It's going to be equal to an object, and I want to think to myself, well, an attack box is just a box. What kind of properties might this have? Well, it's going to have an X, it's going to have a Y, and then it's going to have a width and a height. So the first thing I'm going to do here is try to get this attack box rendered out on our screen and following our player wherever they're going. So if I wanted our attack box to be following our player, what would X actually be? Right now, 0 means we are drawing out the attack box in the top right-hand side of our canvas. But we don't want that. We want this following our player. So X in this case would actually be the X associated with our player that we're moving and updating as we call player.update. What would Y be? Well, it's going to be the same thing, but just the Y version. Where is our player's Y coordinate? And then for width, this is going to be a little different. How wide do we want our attack box to be? Let's just do some sort of arbitrary value, like 20, and then for height, we'll do 5, because I want to make this some sort of rectangle to resemble our player's weapon in this case. So these are all great default values, but next we want to make sure that we're drawing this out on the screen. And we can do that by going into our draw method. We know this is being called for every frame. And if we look up above, we already have a comment right here for red square debug code. I want to leave that as is, but I'm going to duplicate it, and I'm going to call this attack box debug code. So now when I uncomment this out, I don't want to draw this on our player's X or Y coordinate. I want to use the attack box's X coordinate, and then the same for the Y coordinate. I'm just adding in the attack box Y, and we know our attack box also has a width and a height associated with it. So I'm going to place it in those extra locations right there. And let's save and refresh and see what we have drawn out. So you can see our attack box is right there. It is being rendered out as blue. And yeah, that's actually great. We can see that kind of resembles the width and the height of our weapon. But as I begin moving, it does not follow our player, even though we declared up above that the X and Y values should be this.X and this.Y. Really, Anytime we have some sort of property like this within an object, this is only set from the very beginning, on load essentially, because it's called within the constructor. But if we want to update it for every frame, we need to make sure we're actually calling it for every frame. So I'm going to copy where we're setting the attack box, and where we have update right here, I'm going to go to the very bottom of it where we're setting our center, and then I'm going to paste in where we're setting our attack box. So this way the attack box's x and y is always going to be equal to the x and y associated with our player. So if we refresh after saving that, now you can see the attack box is following us, which is great, but really it's not aligning with our weapon. Let's go ahead and make sure that those values are correct and that it is actually lining up accordingly. So if I want this to line up with our weapon, I don't really want to change this .x in this case because I want to make sure that stays the same. It's always following our player. I think it makes sense to add some sort of x and y offset in this case based on which direction we are facing. So we're going to hard code this value first. Let's say initially this .x is going to have maybe 10 pixels added onto it, and then y will have something like 5. And we're going to need to fine tune this, and right now we're only updating this whenever we call update. We will update this, but let's just see how things look right now with those updated values. So you can see the x value is looking pretty good. That extends all the way to where our weapon is fully extended, but it's not really in line with the y value in this case. So we want to push the weapon, or not the weapon, but the box down a bit. And to do that, we're going to add on to our y value, maybe 2 pixels. We just need to fine tune this until we get it perfect. Maybe 9 in this case. And yeah, that pretty much covers the width and height of our weapon perfectly. So now we have some sort of attack box following our player, and it matches up with our weapon width and height, x and y, and so forth. So the idea here is whenever this attack box overlaps with one of our enemies, and we are attacking at the same time, we're going to remove the enemy from the game. We're going to get there, but what I would like to do next is make sure that our attack box is actually moving with our weapon as we change directions. That's going to be very important because it doesn't make sense for us to detect for a collision over here as we're attacking up or to the left or down. So how might we go about doing that? Well, in this case, I want to go back to our constructor, and I'm going to start creating a library of objects similar to what we did with this .sprites right here. But instead of this .sprites, I'm going to create a property called this .attack boxes. So this is going to be our library, and we're going to have attack boxes for each direction in which we're facing. So what direction are we facing right now? It's going to be right. And what is this right attack box? What values does it have within it? Well, we're going to have an x offset. We're going to have a y offset. And then we're going to have a width and then a height. What are these values actually though? Well, we have them down below within our update method where we're always updating this attack box value. So I'm going to copy this and then just bring it back up to our constructor just so I can use the values. And right where we're creating our attack box of right, I'm going to paste it up above, just reference those values. Our x offset I know should be 10 when facing the right. Our y offset should be 9 when facing the right. And then our width should be 20 and our height should be 5. So now I no longer need this temporary attack box right here, but I have all the correct values required to set our attack box in the correct direction, at least when we're facing the right. So initially, let's say that we are facing right, we are not right now. What would we do in this case to make sure that our initial attack box x, y, width, and height is correct? This attack box right here is what's being rendered on the screen. We're currently not doing anything with the attack box's offsets right here. So what do we need to do to make sure that this is always in the correct position based on which way we're facing? Well, really, we need to make sure that we have the player's position, and then we're adding onto that position the x and the y offset of whatever direction we're facing. And if we're adding these on to our player's x and y, where the attack box should be, we can fine tune the exact location of the attack box so that it's facing up, left, down, or right. So we always want the attack box based on which direction we're facing. We're going to add more directions in here. Let's do it right now. I'm just going to paste the right 3 times. And we know that we have a left, we have a up, and then we have a down. And it's very important that you call these exactly what we're setting this dot facing equal to. You can see that this dot facing has a couple of values associated with it when we're setting it. It's going to have right, left, up, and down, and we're setting those when we're handling our input, pressing down on the keyboard with our keys. It's very important that we use those exact values within the attack boxes right here. So you can see we're using right, left, up, and down. And the reason this is important is because we're going to be referencing these values in a very special way. So I want offset added onto our player's X position currently for our current attack box. How might I add the offset of whatever direction we're currently facing? Well, what we can do is say we want to add on this dot attack boxes. So we're referencing this one large library object right here, but we can grab one specific object within this by using an array, and within this referencing this dot facing. So facing is only ever going to be 4 values, up, down, left, or right. And we have those 4 values available to us right here. So the cool thing is, whichever way we're facing, if we're facing to the right, we're going to be getting these values right here and adding them onto this .x. If we're facing the left, we're going to be getting these values by default because this dot facing is always changing based on which way we're moving. So based on which way we're moving, what direction we're facing, we're always going to be getting the correct values in which we need to set the direction, X and Y coordinates, offsets, and all that for our attack box. So we're grabbing one particular object right here within this .attack boxes. Now we can reference the X value, specifically the X offset associated with it. And that's going to move our attack box on the X coordinate to the exact location we need it in when we are facing the right. So we want to do the same thing for the Y value, but of course we don't want the X offset here. We want the Y offset in this case. Now, one thing to note is when we're facing up or down, our attack box width and height is going to be different than what it is when we're facing left and right. You can see right now our attack box has a width of 20, a height of 5, and it is a rectangle, horizontal rectangle I would call it. But when we are facing up, you can see that the attack box that we need to form is going to be a vertical rectangle. So we just need to make sure that we're setting the width and height to something different for when we're facing up or down. What does it kind of look like right here? Well, it looks like we have a width of 5 and a height of 20. And we want to keep that accurate. We want to keep it consistent across all ways in which we're facing so that when we attack in one direction, we don't have an inherent advantage over attacking in another direction. So we need to make sure that these width and height values right here are also dynamic, and that's why I included them right here within the attack box's object. So to dynamically get the width and heights, we can get the attack box for whichever way we're facing, and we know how to do that because we did it up above, and then we can reference the width value for that specific attack box, and then same thing for height. So now instead of a static value, we're going to be referencing the values based on whichever way we are facing. But as I said, when we're facing up or down, those values definitely need to be different for width and height. We want a vertical rectangle. So we're going to swap the values here for width and height for up and down. Width is going to be 5, height is going to be 20 in both of these instances. So now our attack box should technically move based on which way we're facing, but really we're only setting these attack box values on player creation, instantiation, because this is only happening within our constructor right now. All these changes that we just made, we want to make sure that they're also happening within our update method, where we are setting our attack box for every frame. So I'm going to replace this version, of which we're setting our attack box, with the one that we just created up above. And now we should see our attack box moving based on which way our player is facing. And this is working great, but obviously the attack boxes are not in the correct location based on which way we're facing. So this is just going to be a little bit of trial and error to get those attack boxes in the correct spot. We know that the right direction is correct. Let's focus on left. The width and height are going to stay the same, but the X offset for facing the left is going to be a bit different. If we were to face the left, we want to move our X location a little bit further to the left. So maybe subtract from the X offset value in this case. We'll go -10 instead of 10 and see what that looks like. So I'm going to refresh, look to the left, and then extend my weapon. And you can see we need maybe like 4 to 5 more pixels there for the X offset. So I'll change that to 14, and like I said, it's just going to be a little bit of trial and error, maybe 16 in this case. And I like the way that looks. So now our attack box is in the correct position for when we're facing the left and the right. Next up, we need to make sure it's in the correct position for when we're facing up or down, and this is really easy. In this case, all we're doing is changing the X and Y offset for up and down. I'm going to assume the X offset is around 2 in this case when facing up, and it's pretty close, I would say, but obviously our Y offset is nowhere near where it needs to be. Let's subtract negative 14 from this, just a random number off the top of my head. And that is pretty close, maybe negative 15. I like the way the X offset looks, by the way, so we're going to go negative 15 here. And that looks pretty good for facing up. Now we just need to do down. And I'm going to say I want one more added onto our Y offset. And our X offset should theoretically remain the same as the up direction. So I'm going to change that to 2. Refresh. And maybe I jumped the gun a little bit on the X offset. I don't know. I think that's actually okay for now. I'm going to say we're good for the up and down directions in this case. An executive decision on my part. So we have this attack box that is moving with us in all the correct directions, and its width and height is changing accordingly. So now what we can do is detect for a collision between this box and one of the boxes associated with our enemies. And the box associated with our enemy is just its width and height and X and Y value in this case. It's already being set depending on wherever they're moving. So we don't really need to add anything else onto our enemy for what we're trying to do here. But where would we be detecting for collision between our attack box and the enemy? Well, it's going to happen within index.js, specifically within animate. I'm going to find where we're looping through all of our enemies, monsters, whatever you'd like to call them. And here is where I'm going to detect for collision. So we can detect for a collision between a monster and our attack box in this way. We're going to write an if statement. And the very first thing we need to do is we need to get the attack box's X location. So I'm going to get that by saying our player.attackBox X coordinate. And that is going to represent the left side of our attack box. Here, I'll make this blue just so it is more associated with our attack box in the game. This blue box is going to represent our attack box. And what we're doing right now is we're just getting the X value. That is going to be the left side of this attack box. And why don't we actually start with getting the right? I think it'll be a little easier to understand. If we want to get the right side of the attack box, we need to add on the attack box's width. So whatever value this is right here. And we can get that. We already have it associated with each attack box on our player. And so we're adding on the player.attackBox.width. And this is going to give us the right side of our attack box. So we have that. And what we want to do is detect for collision between this right side and then the left side of our enemy right here. So how might we get the left side of whatever enemy we're currently looping over? Well, it's easy enough. We just need to reference the monster and then .x. So we're testing is the right side of our attack box greater than or equal to the left side of our monster, which we're getting with monster.x. And if it is, so it is past that point, then we're going to say, hey, we want to remove this enemy from the game. This is a start, but we need to do this for all 4 sides of our attack box. We just did it for the right side right here. But we also need to do the same thing for the left side, as if our attack box was coming in from the right and entering into the enemy through its right side. A little confusing to say, but that's essentially the gist here. So now we want to get the left side of our attack box and the right side of a monster. So we're going to add an AND operator here, and we want the left side of our attack box. We get that with player.attackBox.x. We want to say if this is less than or equal to our monster's right side, which we can get with monster.x plus monster.width, then we know that our attack box is colliding with the monster in this case. So that's going to take care of things for the x-axis, but we also need to do things for the y-axis. Let's say our attack box in this case, we're coming down. Our attack box's bottom side enters through our enemy's top side. How do we detect for a collision with code? So we want to get the bottom side of our attack box, and we'll do that by adding an AND operator. And to get the bottom side, we'll say our player.attackbox.y plus our player.attackbox.height. That gives us the bottom coordinate of our attack box if that is greater than or equal to the top side of our monster, which we can get with monster.y. Then we know we are colliding from that direction. And you can kind of get the idea here. It's kind of like a pattern. Now we just need to do the same thing for the top side of our attack box. So how do we detect for a collision then? We add an AND operator, and then we get the top side of our attack box with player.attackbox.y and say, is this less than or equal to the bottom side of our monster? And to get the bottom side, we can get monster.y plus monster.height. So this if statement right here takes into account all directions. If our attack box is entering the enemy from the bottom, top, left, or right, we know in this case that the two are colliding. They're overlapping with each other just with this simple if statement. But obviously, we want to test this out. So we're going to console log out, collision in this case, refresh. I'm going to inspect, go over to console, and now we should see some text logged out whenever an enemy enters this box right here. And there you go. You can see it only happens exactly when the enemy is actually overlapping with the box. Let's test that all directions work. Seems to work when we're facing the left, works when we're facing up, and then it works when we're facing down. So yeah, we just wrote really good collision detection right there. Now, what we want to do is splice out an enemy whenever it touches this attack box. Eventually, we're going to make sure that it only removes the enemy when we're actually attacking. But to start, when an enemy touches this attack box, we're going to remove them from the game altogether. So instead of console-logging out collision, like a scrub, we're going to grab our monsters array, call splice on top of that, and the splice method within JavaScript says, from what index within this array do we want to remove something? Well, we have the index available to us as we're looping through everything, and we want to splice out just one item from that index, the current monster in which we're looping over. So that's all it takes. If we save that, refresh, and then start hitting enemies with our attack box, you can see that they're just removed from the game altogether. And I know that we have some enemies down here as well. You can see I'm pretty much just unstoppable at this point. Wherever my blue box goes, the enemies get removed. Pretty cool. But really, we only want them removed when we're actually attacking. So how might we differentiate between when we're attacking and when we're not? Well, thankfully for us, the way we set up our code, our player has a property called this.isAttacking. So we can add on to our conditionals right here that says if our box is overlapping with one of our monsters and our player is attacking, we know that they are within the attack state, then what do we want to do? Well, we want to splice the monster out. So that's all it takes. Save, refresh. You can see the monster is not removed by default, but when I attack, now they are. Really cool stuff right there. So we know that this is working for removing an enemy as if they have no health. I think the next thing I'm going to do is just uncomment out the blue box debug code, just so we can really see how things are looking here. I just want to make this as fine as possible. So I'm going to comment that out and go back, and yeah, whenever I hit an enemy, they get removed. Perfect. But what if we wanted to give our enemy some health? We don't want them removed immediately from the game. It kind of makes it too easy. And we want to start adding some, what would you call it, some dynamic values within our game so that enemies can have different amounts of health. They react to different weapons that our player has maybe in a different manner. So what I'm going to do is give our enemies 3 portions of health before they are removed from the game. So we can hit them 3 times before they're removed. And to do that, we want to go over to monster.js and set a new property within our constructor. That constructor property is going to be called this.health, simple enough. And by default, I want it set equal to 3, but maybe I want this to be a dynamic value based on what kind of monster type we're using. If that's the case, I would set it equal to an argument called health. And if we're using this argument here, we need to make sure that it's passed through within a constructor, so health. And by default, this is always going to be a value of 3. So every enemy currently has a value of 3 for its health. And now as our player hits the enemy, I want to decrease this value by 1. So I'm going to add a method within monster.js called receiveHit. And what happens when a monster receives a hit? Well, we take their health and we subtract 1 from it. Shorthand syntax right here, minus minus, just says take the current health and subtract 1 from the current value. So we're subtracting 1 from it, but we need to think to ourselves, if we were to hit an enemy and call receive hit, we are determining whether or not the enemy was hit based on whether or not our attack box is overlapping with an enemy. But our attack box could be overlapping with an enemy for multiple frames. And if that is the case, our health is going to decrease very, very, very quickly. So much that it doesn't even look like an enemy has health in the first place. I want to make sure that I'm only calling receive hit if a certain amount of time has passed. So I'm going to give our enemies a little bit of invulnerability, a small invincibility buffer, so that we hit the enemy once. We can't spam attack or anything, and the enemy is just removed from the game completely because our sword is overlapping with the enemy. So we need some sort of invulnerability in this case, invincibility, whatever you want to call it. And here's how I'm going to do it. I'm going to add a property called this.isInvincible. And by default, an enemy should not be invincible, so we'll set that equal to false. But as soon as an enemy receives a hit, I do want to set this property equal to true. And eventually we're going to set it back equal to false. But a certain amount of time needs to have passed before we do that. So to track how much time has passed, I'm going to add a few more properties here. One is going to be called, let's say, elapsed invincibility time. And by default, that'll be equal to 0. And then I'm going to have another one called invincibility interval. How much time should pass before we set this.isInvincible back equal to false. So I want these two values right here. And now I want to change this.isInvincible to false after 0.3 seconds have passed. And we're going to do that with an update. So I want to say, if our enemy or monster is invincible, then I want to call the following code. I want to start adding on to this.elapsed invincibility time, because we know that as soon as we set this.isInvincible to true, enemy is invincible, how much time needs to pass since that moment. And the time in which we're tracking is going to be set within this.elapsed invincibility time. So we need to start adding on to that value as soon as this.isInvincible is set. So this.elapsed invincibility time is going to have delta time added onto it. And that's going to give us total amount of time that has passed since we are invincible. And now we can say within this if statement, if this.elapsed invincibility time is greater than or equal to our interval, this.invincibility interval, we know 0.3 seconds have passed. And then if that is the case, we want to take this.isInvincible and set it back equal to false. Also, we want to set our elapsed invincibility time back equal to 0 so that we can repeat the process if we ever hit an enemy again. So this is looking great, and we're getting there. It's not actually going to function just yet, but let's start making it function. We need to make sure that our enemy is receiving a hit. When should an enemy receive a hit? Well, within index.js, when we are splicing out an enemy, or when we're detecting for a collision actually, we're going to call the current monster we're on and say that they should receive a hit in this case. But I only ever want to splice a monster out if the monster's health is less than or equal to a value of 0. That is the only time in which we're actually removing a monster. Otherwise, they should stay within the game. So to test that this works with our invincibility and so forth, I want to console log out our monster's health each time they get hit. We should only see this decrease for every 0.3 seconds when we're hitting an enemy. We shouldn't be able to spam this, is basically what I'm trying to say here. So let's test this out just to see how we're doing with everything. I'm going to refresh over here, go to inspect, check out our console, and then I'm going to hit an enemy. And it looks like it's not working accordingly. Our health just decreased immediately. And that's one of the problems we were trying to fix here. So what's going on? Well, let's check out monster.js. Whenever our attack box is colliding with an enemy, we're calling receive hit as fast as we can for every frame within update. And you can see, yes, we're setting is invincible equal to true, which means we shouldn't be able to hit our enemy or decrease its health. So why are we decreasing our health in this case if we are currently invincible? So, okay, yes, maybe we should be able to receive a hit still, but we only want to decrease our health that says if we are invincible, then I want to return. I do not want to subtract from our health, and I don't want to set is invincible. It doesn't even matter in this case because it should already be true, but I only want to set back equal to false based on when 0.3 seconds has passed with that code we just wrote down here with an update. So I believe that's all we need to fix this, is just making sure that we're not subtracting from our health if we are currently invincible. So we'll save, refresh, and now when we hit an enemy, you can see that their health is now 2. I should probably open that back up actually. Now it's 1, and then when it gets down to 0, we remove them from the game altogether. So the next thing I would like to do is actually indicate that an enemy was hit, because it's not very apparent at the moment. And I think a simple way to do this is to just fade out the enemy a little bit when we actually hit them with our spear. So to fade the enemy out, we're going to go to monster.js, and within draw, this is where we are changing all of our rendering code for what's actually drawn out on the screen. I'm going to call c.save, and then at the end of draw image, I'm going to call c.restore. And the reason I'm doing this is because I'm about to use a global canvas method. We've done this a little bit throughout the tutorial, and the one I'm going to use is called global alpha. What this does is it changes the transparency value of whatever code is within c.save and c.restore. So if I were to change this to 0.5, we should see all of our enemies faded out, and you can see that right there. Doesn't really make sense in this case unless we're drawing out ghosts, but I do want this value right here to be dynamic. So I'm going to assign global alpha equal to a value of alpha, and I'm going to create a let up above that by default sets this to a value of 1. Everything is drawn out completely on the screen by default. But if the enemy is currently invincible, I'm going to change this value to 0.5. Save that, and now when we hit an enemy, you can see that they are invincible for a small amount of time. So that is looking great. But one issue that I did come across while testing this out was sometimes I would only attack twice, but an enemy would still disappear from the screen because their invincibility runs out while my spear was still out. I don't really want that to happen. I think it was, I don't know, it just felt like a little jank as I was testing it. So what I'm going to do is make sure that for every time I extend my spear, only one enemy can get hit at a time for that one attack that I initiated. And to do that, we can go to player.js and create a new property within our constructor. And the property I'm going to add in is called this.hasHitEnemy. And of course, this is going to be equal to false by default. But now what we can do is within index.js say that if we hit an enemy receives a hit right here, we can change player.hasHitEnemy equal to true. And now we can use this as a condition that says we only want a monster to ever receive a hit if a player has not hit an enemy. So I'm going to add an and statement here that says if a player has not hit an enemy yet, then that is when we want them to receive a hit. We know in this case they hit him, we set that equal to true, we can't call this code again, but we do want to set this back equal to false within player.js when the attack state has completely ended. So really when we're switching back to our idle state, we can add this at the very end that says this that has hit enemy is equal to false in that case. So we're sending it back equal to its original state because we're always looking to switch back to our idle state at some point when our attack is ended. I guess theoretically we could also add that code right here that says has hit enemy equal to false. Might make more sense in this case to put it there and just leave this method to changing the sprites. I think I'm going to do that. But yeah, I think that should get rid of the rendering issue completely that I was experiencing earlier. So let's save that, refresh, and now when I hit an enemy, yeah, I do not see any instance yet in which an enemy can kind of lose their invulnerability over our spear and just disappear from the game completely. So this is a much more reliable and snappy way to make sure that the enemy is removed from the game in a valid manner as we go about attacking them. But yeah, that's pretty freaking awesome. I love the way this looks. It's very responsive and snappy, works for all of our enemies, and we have a way to tell that they were hit. So that is going to be how we add interaction to our attacks between our player and our enemy. So the next thing we're going to do is add collision detection for our player and the enemies. It's not much of a game if we're just going around removing it from the screen as we attack. Obviously, we want the enemies able to attack us. So if an enemy runs into our player, we want to start decreasing a health bar in which we're about to add. So health bar in this case is just going to be simple enough, a few hearts drawn out in the top left hand corner here. These are the best hearts that I can do with my mouse. I can't even change them to red for some reason. There we go. Okay, just the way things work in this world. But enough rambling, you get the point. We're going to add some hearts up here. And as an enemy hits us, we're going to deplete the hearts. And eventually when we get down to 0, we're going to say it's game over. So how do we start getting hearts in the top left-hand corner here? Well, this asset pack that we have is actually really freaking incredible. If we look inside of it, we're going to have so many things. I wasn't even aware of how many things are within this asset pack. But one thing that it does have is a UI folder. And if we look inside of here, we have a life receptacle folder. So if I were to search through this, we have heart 2, heart 3, and heart.png. So we have different ways in which we can represent our player's life. Maybe this could represent some enemies' life bars as well. Triforce looking thing here is really cool. I love that. But I do want to go with the traditional route here. I think this is the most understandable to deplete these hearts over time. So how might we go about getting this in our game? Well, first thing I want to do is copy heart.png, and then we're going to go over to our folder, Ninja Adventure, and paste it within images. So now that is available to us, we can begin to use it within our game. So there it is. You can see hearts are now available. And how might we add this into our game? Well, we want to create a new class in which we can draw out a sprite. That's going to be the first thing. So that sprite class is going to be rendering out these hearts right here. How do we create this sprite class? Well, it's simple enough. We just want to go inside of our classes folder. We can create a new file and then save it within classes. And I'm going to call this heart.js, self-explanatory. Preemptively, I'm going to go into index.html and make sure that I'm pulling in this new class by duplicating a script tag and replacing the current script with a script of heart.js. So, simple enough, referencing our new class right here. I can save that, but heart.js is pretty barren. We want some stuff inside of here. And I never recommend just writing this all out from scratch. That's annoying and tedious. No one wants to do it. I'm sure you don't want to do it following this tutorial. Just go to the Git repo and copy and paste it. No, but if you're trying to learn here, we can start from just grabbing some default code within player.js. Player.js is actually, I'd say, the closest class that we have to being able to achieve what we want to achieve. The main thing I want to grab from player.js is the ability to pull in an image and draw it out on the screen. So what I'm going to do is I'm just going to copy everything within player.js, paste it within heart.js, and here's what you want to delete. Pretty much everything besides your draw method. So that is exactly what I'm going to do. We don't want to update either. We don't need that. Here is our draw method. We can keep that for now. We don't want switching back to idle state, but we do want our constructor. We definitely want that. But what within our constructor can we get rid of? Well, we can get rid of any of our attack boxes. Really, the only thing that we want to keep is things related to our current sprite. We don't even really need this giant sprites object anymore. I know this is just kind of tedious right now, but what we do want is a current sprite. And what is a current sprite value? Really, these are just the crop boxes associated with one of our sprites. So I'm just going to grab one and then make sure that I delete this .sprites. And then our current sprite is always going to be just this one object value. Because I know this heart sprite in which we're using is only ever going to have one crop box. Like, we don't need to go up or down, left and right throughout the sprite sheet, really. We do need to go left and right, but we're never going to go to like a different state where a player is running like we are within player.js. So that's what's going on here is I'm just kind of consolidating this down to current sprite. We can keep current frame. We're going to want to use that. But what else can we get rid of here? So we don't need a weapon. I really just want to keep everything related to the image loading. We don't need velocity. You can get rid of that as well. Size, don't really need that either. We can just replace these with static values. I'll go with 2020. I think this is all we need in this case to start drawing out a sprite. We're going to fine tune, draw a bit, and we don't need anything related to attacking or drawing out a weapon sprite in this case. We just need like c.drawImage. Maybe we could keep debug code, but okay. That might have been a little more work than I thought it would be, but this is what we want to start with, is just a simple class, not called player, but rather heart. Something that loads an image, but we don't want to load player.png. We want to load heart.png instead. And yeah, I think that is all we need to get this rendered out on the screen. So now we can instantiate some hearts within our game. And to do that, we'll go over to index.js, find animate, and I want to create a new const called hearts. This is going to be an array full of all the UI hearts, which we're going to draw out on our screen. So let's create some new hearts inside of here with new heart. And what does a heart take? We can look within our arguments. It takes an X and a Y that sets its position on the screen. So I want these relatively close to the top left-hand corner. Therefore, I'm only going to say that X and Y should be 10 in this case. So only 10 pixels from the top left-hand corner of our screen should place our first heart right about here. So how do we get it rendered out on the screen? Well, we're going to want to loop through all of our hearts within our animate function. Very similar to how we are calling player update, player draw, monster update, monster draw. We're going to do the same thing for our heart sprite, but we don't need to loop backwards through our hearts array because we're never going to be removing hearts from our array. We're just going to be changing the crop position of the hearts to tell whether or not they're depleted. So if we don't need to remove anything from an array, we can loop through them using for each, the nice syntax. So right after where we are looping through our monsters, I'm going to reference our hearts, and then loop through the beginning of our array by saying dot for each, the native JavaScript loop method. And I want to say for each heart, within this hearts array that we're looping over, what do I want to do? Well, I want to call heart.draw. And our draw method here takes our canvas context, which is C. You can see that being referenced right here so that we can call c.drawImage. And that should get a heart rendered out on our screen using this images.heart object. So let's go back to our game, refresh, and now you can see a heart is rendered out on our screen. It's as easy as that. It's pretty cool. So we want multiple hearts in this case, and to create multiple hearts, it's pretty easy. We just need to go over to index.js and add more hearts to our hearts array. So I'm going to duplicate one heart instantiation, paste it 2 more times, and then I need to change the X position. So we'll say I want to add, I don't know, maybe like 22 pixels onto the X value. We'll see how that looks. That seems about perfect to me. I want 22 more pixels added onto this. So that would give me 54 for our third heart. And now we have all the hearts in their correct position. Now there is a little bit of black and white edge there, and I think the heart sprite was probably a little bit better laid out than it was for the player sprite. We can get rid of the 0.5 in this case. I think that is going to look a little better. Maybe not. It's okay regardless. I don't think it's that big of a deal. But this is looking to be in good shape. So I don't want the depleted hearts by default. You can see that all these are empty, but if we look within our heart.png sprite sheet, we have different ranges of heart. I'm really only going to deal with the first one right here, and then the last one right here. If an enemy hits us, then I'm just going to go straight to that state. But by default, I want this full state. So to make sure that I'm rendering that out, all I need to do right here is change our current frame to the very last frame of our sprite sheet. And we have 5 frames, but we start by counting from 0. So we have 0, 1, 2, 3, 4. That's going to mean we want to use 4 for our current frame. Now, our player sprite sheet is basically has us moving around the crop box on the y-axis. But for our heart sprite sheet, we need to move our crop box on the x-axis. There is no other sprites on the y-axis here. And if that's the case, we don't want to do this. We don't want to be adding on the current sprite's height and current frame for the y value of our crop box, but rather we want to do this for the x value, but not reference our current sprite's height, but rather our current sprite's width. And as long as we change that, now when we change current frame equal to 4, we should see all these filled in, and there we go. So if we wanted to deplete these over time, the idea would be when we run into an enemy, we're going to change this value right here, current frame, equal to 0. And that's going to render out the depleted version of the heart. So that's going to be the next thing we do, is add interaction between our player and the enemies. So right here within index.js, within animate, where we are rendering out our monster is detecting for our attack box, collision, and all that. Now we're also going to detect for a collision between our player's overall width and height and one of our monsters' overall width and height. And to do that, we can reuse this if statement that we were using for our attack box, checking for a collision between our weapon and the enemy. So I'm going to paste it down below after I copy and paste. And now I don't want to detect for a collision with our attack box. So every instance of attack box here, I'm going to remove it, and now I'm referencing our player's x, width, and height, and also the player's y value. And I don't need to determine whether or not our player is attacking or whether or not they have hit the enemy. I just want to know, has our player run into an enemy? And this is all the code that we need in order to detect that. So we don't need any of this code either, but I will console log out player hit if we run into an enemy. Just want to test that this works as we go about our project. So I'll open up our console. And now when we run into an enemy, you should see player hit, and there it is. It's a little hard to see because my browser is huge or small for this tutorial, but yeah, now you can better see. When we run into an enemy, that is indeed being called. So what do we want to have happen? Well, pretty much the same thing that's happening for when we hit an enemy. We want our player to become invincible. We also want to deplete our hearts, which seem to be missing now because they're not actually following our screen in a fixed manner. Let's just fix that right off the bat. If we want the hearts to follow us, right now they're being translated with our canvas and our map as everything is moving. So you'll see right here, our horizontal and vertical scroll distance is translating everything, including the hearts in which we're drawing out right here, because the hearts are being drawn out within that same c.save and then c.restore. It's wrapped within them. We do want our hearts wrapped within a save and restore so that we can scale them up, because they're going to be very small if we're not scaling everything up, but we do not want them in the same save and restore as where we're translating everything. If we do that, then they're going to be moved within our scene. So if we want these to be fixed, what we can do is right after the last restore, we can add in a new c.save and a c.restore. And then we could take our hearts code, paste it within those two, and you're going to see what I mean in a second in regards to why we want these scaled up. If I save that, these are just way too small. It's very hard to see, but they are there. We want to scale them up with the rest of our scene because our tile set is only 16 by 16 pixels wide for all the tiles. And to do that, it's pretty easy. We just need to grab the c.scale that we're using up above. This says scale anything within the save and restore to whatever values are within it. And I believe we set this equal to 4 up above. Just save with the scale inside of the new save and restore. And now those are looking much, much better. And they follow us wherever we go on the screen. So back to where we left off. We want to start depleting these hearts, and we want to make sure that our player turns invincible after an enemy hits us, after we've collided with them. So how might we go about doing that? Well, we can really just duplicate the same kind of code and functionality that we were using within our monster.js code. So what do we really need here? We need to be able to receive a hit from a player. An enemy hits us, we're going to call receive hit. Let's start with that. I'm going to copy this method from monster.js and then paste it within player.js. So right beneath our constructor, I'll add in that method. And does anything need to change here? Well, I don't really think I need to track my player's health. I'm going to do that separately. Maybe it would be better code practice to do it here, but I don't think we need it. So I'm going to remove this .health in this case. And just make sure that we're setting this.invincible equal to true when our player receives a hit. Now, if I want to use this, I need to make sure that this property is available to us, and right now it's not. So I'm going to go back on over to monster.js, and I'm going to copy everything related to invincibility. These three properties right here, because I pretty much want to do the exact same thing for player.js. I'm going to take those, paste it within player.js's constructor, and now we're able to use this property, but we're also able to use elapsed invincibility time and invincibility interval. But we don't have a way to use them yet. We know how though. Within monster.js, within update, we have this small snippet of code that tests whether or not we're currently invincible. If we are, we start adding on to elapsed invincibility time, and then if that is past our interval, if 0.3 seconds have passed, we are no longer invincible. We can get hit again, and we reset everything. So I want this small snippet here, and I want to go to player.js and paste it within update, very similar to what we did within monster.js. I'll do it right after elapsed time. It's not that big of a deal, honestly, where within update we put it. But I think things should function as expected with this. So before we actually test this out, I do want our player to have some sort of transparency value associated with them when we get hit. And if that's the case, I need to go to draw, call c.save around c.drawImage, and then c.restore. And what's going to happen here is same thing that's happening within monster.js's draw method. We can see that we grabbed an alpha value, and if we are invincible, we're setting it equal to a value of 0.5 to say that we can no longer be hit or harmed in this state. I want to do the exact same thing within player.js's draw method. So I'm going to do exactly that and say that if we're invincible, then I want c.globalAlpha to be equal to the new alpha value in which we're transparent. Now, this isn't the only c.drawImage location I want to do this at. If we look down below, we also want to make sure that our weapon becomes transparent. We just pretty much used a separate save and restore here so that we could rotate our weapon as needed. So within this c.save and restore, I also want to set the global alpha equal to 0.5 to make sure that our weapon is transparent too. So at least now we have some sort of visual indicator in regards to whether or not our player is invincible. But we need to make sure that all this works. And back within index.js, when a player gets hit, we want to start the invincibility state, not invisibility, but we only want to become invincible if we're not currently invincible. That means we need to add one more AND operator that says if our player is not invincible, then that is when we want to call player.receiveHit. So given we did all this right, we should see our player turn transparent for a brief period of time when we run into an enemy, and then after about 0.3 seconds, we should return to the normal state. I'm going to refresh with the console open, no bugs, always a great sign, and when I run into an enemy, you're going to see we enter that state. It's very quick because it's only 0.3 seconds, but we know it is indeed working, which is absolutely perfect. So the next thing we want to do is start depleting these hearts. We have the player state working correctly, but how would we deplete the hearts? Well, we could say if our player is not invincible, then we're going to go through that invincibility state. We have that brief period of time in which we're only going to call the code inside of this if statement once, even though this if statement is being run for every frame within our loop. So I want to grab specifically all the filled up hearts within our hearts array. And based on the very last heart within the array, I'm going to set its current frame value equal to 0. And if we do that, we should get a depleted heart for the very last heart within our hearts array. So let's grab all the filled hearts. And to do that, we can grab our hearts array, call an array filter method on top of that that says we want to grab only the hearts that have a current frame of 4. This represents a totally filled heart. So we're saying loop over all the hearts, check which ones have a current frame equal to 4, and if they do have 4, then we're storing all of those within a new array called filled hearts. And now that we have this new array, we could say as long as filled hearts.length is greater than 0, we could take the very last heart within this array. And we can do that by referencing the array, and then within it, grabbing an index of filled hearts.length minus 1. This will always give us the very last item within an array. And then we could say we want the current frame equal to 0, which represents a depleted heart in this case. And I think that should be it for rendering out a depleted heart. Let's test it out. Now when I run into an enemy, you're going to see that depletes, but only for the time in which I am not invincible. We'll do it again. We can always decrease or increase that invincibility interval depending on what you want. Maybe I will increase it because I think it's kind of short right now to 0.8. So within player.js invincibility interval, I want my player to be a bit more invincible, for a bit longer at least. I'm going to change that to 0.8. Now you can see that lasts a bit longer. We're only ever depleting our heart when we are not invincible in this case, which is perfect, exactly what we want. And really, all there is to it now is when we have 0 hearts, we want our game to be over. Now your game could be over in a multitude of ways. It really depends on where you want to go with this, but I think just to show you that our game is over, I think the easiest way is just to console log some text here. So we can tell that our game is over by adding in one more if statement that says if our filled hearts array dot length is less than or equal to 1 in this case. And the reason I'm saying less than or equal to 1 is because let's think about this. Well, if we only have 1 filled heart in this case, meaning 1 life left, we get hit, we set that equal to 0. Game over, right? Well, we technically still have 1 heart within our filled hearts array. Even if that was set equal to 0, well, that is kind of when we want to do a game over right here. So I'll console log out the text game over. And I think that should take care of getting that out here correctly. So I'm going to open up our console. And now, when we hit an enemy and our hearts go down to 0, we get that text of game over. So really, this is where you would want to present some sort of user interface for your player to get some sort of real game over method so that they can restart their games. I don't know, save it. You get the idea. Think of like the original Zelda games. But this is the most bare bones way, I would say, to do it. And yeah, it's looking great so far. So that is how we're going to add hearts and interaction between our player and the enemies on our screen. So the next thing I want to add into our game is going to be a few particles. And by particles, I mean leaves coming from the top left-hand side of our map towards the bottom right-hand side. I think it'll create a really cool dynamic effect. Just a little something to bring out some liveliness into our game that it might be missing right now. So to begin creating these leaves and particles, if we go back to our Ninja Adventure asset pack, why did I exit out of it? I don't know. But here it is. We can go inside of this FX folder. It stands for effects. And there's going to be a folder for particles. And there's a lot of cool particles in here, but the one we're going to focus on is leaf.png. So this is another sprite sheet. We want to copy this and put it into our image folder. So I'm going to copy it, and then I'm going to go back to our game Ninja Adventure, and then paste it within images. And the last thing I'm going to do is make this a lowercase l, just so it is consistent and easier to reference when I'm using it within the project. So here is leaf.png, hard to see, but maybe I can zoom in. But yeah, you get the idea. This is what we want to use. Now, to render these out on the screen, multiple leaves at the same time, and create some sort of movement with them, we're going to need a new class. And we might want to use more particles in the future. So it would make sense to create some sort of generic class in this case, rather than one that is specific, like leaf.js. And to create a generic class, I'm just going to create a new tab right here, hit Command S, and I'm going to call this Sprite.js. So this generic class is meant to render out an animated image on the screen, and really nothing else. I don't want any other kind of interaction with this one generic class, and we can always extend this as needed. Maybe we should have done this from the beginning. I don't know, but I think it's totally fine for what we're about to do right now. So if I were to think to myself, out of the classes that we have, heart, monster, player, collision block, which of these is closest to a generic sprite class? I think I want to go with heart.js because here we are rendering out an image, we have some animation associated with it. Possibly if we just changed a few things. This is really bare bones, and I think this is all we need to get going with a Sprite class. So I'm going to copy everything within heart.js and then paste it within sprite.js. And I need to make sure that I'm changing this class name to Sprite. And then I need to make sure that I'm importing this class into our game. So we'll go to index.html, copy one of the script tags, and then reference sprite.js. So now that's pulled into our game. Let's get some sort of sprite rendered out on the screen. To do that, we need to go to index.js and call sprite.js's draw method. So I know I want multiple sprites on the screen, and whenever you have multiple of anything within the realm of JavaScript, Canvas, games, we want to create an array. And this array I'm going to call leaves. Now what is inside a leaves array? And actually maybe it should be leaves. I'm not really sure how to spell leaves actually. I'm 31 years old and I don't know, but we're going to go with this one. So we want to create a leaf from this new sprite class. And to do that, simple enough, new sprite, because that is what it's called. And then what arguments does it accept? Currently an X and a Y, no problem. So we'll create an object, say that this sprite should be at an X of 100, a Y of 100, and now we need to begin drawing out all of our leaves. Well, at least this one leaf. So to draw it out, we're going to draw things out the same way we're drawing out our monsters, because within our leaves array, I want some of the leaves to disappear and be removed from our game altogether. So whenever we're removing anything from an array dynamically, we need to loop from the back of the array. And that is exactly what we're doing when rendering out our monsters. So I'm going to copy this for loop right here, and I'm also going to copy the 3 lines beneath it where we're calling update and draw. And I'm going to call this as the very last thing within our first c.save and restore, because I want all of our leaves drawn on top of everything except our hearts GUI that we have in the top left-hand corner. So I'm going to draw it right after front render's canvas, everything that should be within that front render's layer. And we need to change a few things here. One, we're looping over our leaves array now, not monsters, so we'll swap out monsters with leaves. And then, yes, we could use a constant monster, and it would still reference our leaves, but we need to be descriptive here. So instead of creating a const of monster, this is going to be a const of leaf, singular. Now we currently don't have a leaf.update method. We will create one, but for now, let's comment it out and just call draw. I just want to see the leaf drawn out on screen. Right now, we're going to see a heart, because if we look within sprite.js right here, we have images/heart.png for our image. Totally fine right now, but let's go back to our game, and there is our leaf. So now let's reference the correct sprite sheet. We don't want a heart in this case, but rather a leaf.png. And the whole point of creating a sprite class was to make it like generic, right? If that's the case, we don't really want to hard code a leaf right here, so I'll show you the correct way to do things with a generic class. We would want to add in an argument here called image src, image source, and here we could say that the default would be images/leaf.png. And we can replace this hard-coded value with image source. This is the exact same thing, but what this allows us to do is, if we're creating a new sprite using the sprite class, we can add an argument right here of image source, change it to something else, and it's going to override this value and set our new image to the image source that we have up above. So that's a way to make this dynamic. And we would need to change out a few things, like the current sprite, current frame, those would need to be dynamic as well. But yeah, for this tutorial, probably don't need to go too far into that realm. So let's just keep going with the leaf. Let's just get the leaf drawn out on the screen. The current frame for our leaf sprite sheet is going to be 0. We're going to start at the very beginning, at least to start. And with our current sprite, what should the width, height, and frame count be? Well, let's go back to Finder and find out. We have 1, 2, 3, 4, 5, 6 frames. And we have 72 pixels wide right here and 7 pixels tall. So let's change our height to 7. What is 72 divided by 6? It is 12. So we'll change our width to 12, and then our frame count is going to be 6. So let's save that, refresh, and now we have a leaf drawn out on the screen. Although obviously it doesn't look very great. We will change that up in a second. So obviously this is super pixelated, does not look great. To make sure this is the actual size, you can see up above within our constructor that we're setting a width and height to static values of 20. Really, we already figured out what the width and height of each individual leaf would be, and that was going to be 12 and 7 for width and height respectively. So we'd want to make sure that we change those two values, and now you can see that the leaf is rendered out way better than it was before, looking really good. But we need animation for this leaf, and we've done animation already within this tutorial. So let's go to a class that is using animation. I know player.js has it, and specifically, it is within our method of update. We look right here, we have an update method, and down below, right here on 284 for me, this is really where the animation magic is happening. So I'm going to copy everything from this if statement all the way to update, then go back to sprite.js, and paste it in and make sure that I add an ending bracket there, because I did not copy the ending bracket. But yeah, this just simplifies things and allows me to delete only what I need to delete here. I know I don't need anything related to invincibility. I don't need anything related to attacking for a generic sprite or a leaf in this case. I really just need to make sure that elapsed time is here and that we have all this code related to adding on to elapsed time and then going to the next frame. But if we're going to put this code within this update method, we also need to make sure that these properties are available to us up above, and it already looks like this .elapsed time is not available to us. So I'm going to say that this .elapsed time is equal to 0 as a property within our constructor, and do we need anything else? In this case, looks like we have current sprite, we have our interval right here on when to go to the next frame. Looking good. I think the next thing we need to do is we can get rid of collision blocks here, and we're going to need to call update within our animation loop. So let's go to index.js and find out where we're drawing our leaf. Here it is right before that. I'm going to call its update method now. And let's get rid of the collision blocks, don't need that. But yeah, now we should see some animation in place because we're calling update, which in return calls update here and is adding on to our current frame. So we'll go back and now we have animation in place for that one singular leaf. Now I want our leaves to be generated in the top left-hand corner here along the trees, and I want them to travel to the bottom right of the screen to create some sort of wind leafy effect as if leaves are being blown from the trees. It makes sense in this case. So really I would want this leaf spawned somewhere closer to the trees. Let's change the spawn location where we're creating a new sprite and say that the spawn location to start should just be 1010. We'll go back to Chrome, and you can kind of see right there. Maybe a little further, 2020 would be better. And yeah, it's behind our heart, but we're about to get this moving. So to get this moving, I'm also going to add in a velocity property to our sprite constructor argument instantiation thing going on here. And this is going to have an x and also a y. Our x will be, I think, when I was going over this, I think I used 0.08. So let's just set some arbitrary values here. Say that 0.08 is our velocity for x and y. And if we're using this new velocity argument, we need to go back to sprite.js and say that we have a velocity argument coming in. Now we don't have a property declared within our constructor. We need to create that, so this .velocity is equal to the velocity we are passing through here. So let's save, refresh, and still not seeing anything. Because yes, we are setting this velocity actually, but when we're calling update, we need to make sure that we're updating our sprite's position. So update sprite position right here. And to do that, we grab our current x coordinate and add on to the current value the velocity that we just set up above. So we want to do this for both coordinates, x and y. And now we should see the sprite being moved. So refresh, and there goes our leaf. Looking really good, love the speed there, but eventually I want this leaf to fade out and be removed from our leaves array. Reason being is if we just keep letting this go on forever, well, it's still using computational power in this case, and we're going to be spawning more and more leaves, it's going to bug up our game and really make it not responsive. Not something we really want in this case. So as our leaf continues to travel over time, we want it to fade out eventually. And if we want anything to fade out, we need some sort of new property called this.alpha. And this is going to represent how transparent this leaf is going to be. We did this in a previous lesson. And whenever we have an alpha value, we're pretty much always going to use it within our draw method. And to use global alpha, we need to wrap whatever we want to have become transparent within save and restore. And then we need to call c.global alpha. And in this case, we're going to set it equal to the dynamic property of this.alpha. Now, this won't change anything until we start editing this property right here. So within update, at the very end, I'm going to say update leaf opacity /alpha. When should we start subtracting from this .alpha? Well, I'm going to say if this total elapsed time has passed 15 seconds, then I want to start subtracting from this .alpha. And I'm going to subtract 0.01 for every frame. So eventually this .alpha will be equal to 0 or something less. And if we ever try to set global alpha to a value less than 0, our canvas is going to bug out. So what we could say is this .alpha should always be equal to the maximum value of 0 or itself. And what this does is it clamps the value so that we can never make alpha something less than 0. And that's going to save us the headache of the bugs that we might see in the future. But we do need to create this property of total elapsed time. We don't have it available to us within the constructor. So I'll say this total elapsed time is equal to 0 to start. And yes, we do have elapsed time being used already, but this is being reset for every animation frame interval. So it's not really feasible in this case for what we're trying to do. To get the total elapsed time for the sprite, I'm going to duplicate where we're adding on to delta time, make sure I'm referencing total elapsed time, and we're just going to add our delta time onto that. But this is going to allow total elapsed time to grow much larger than this elapsed time value, including something greater than 15 seconds. But to test this, let's just say that when the total elapsed time is 2, then that is when we're going to start fading things out. That way we don't have to wait 15 seconds. So after 2 seconds, we see that fade out. Probably want to open up our console. No bugs. Looking great. But we're not done. Although it's faded, we still have that leaf sprite within our game. So there's a few things we can do here. 1, we can just reposition the sprite, or 2, we can remove it from the game altogether and then generate some new ones. I think it's okay to remove it from the game altogether. So within our animation loop in index.js, where we're looping through all of our leaves, we're already looping through things backwards. That's great. We could say if this.leaf.alpha is less than or equal to 0, then we want to take our leaves array and splice out this one particular leaf. So eventually, I'm going to console log out just a string leaves. We still have leaves. After 2 seconds and our leaf has faded out completely, we are no longer going to see this console log, or at least we shouldn't. So save and refresh. There is our leaf. We're console logging, and it disappears. It's removed from our game. It's no longer in the array. Looking great. So the next thing I want to do is start to spawn multiple leaves. And to do that, well, I'm going to need to track the total amount of elapsed time here. So I'll create a let called elapsed time. By default, it will be equal to 0, but we're going to start adding on to this as soon as we get our delta time. So whenever we call a frame within our animation loop, I'm going to add on to elapsed time, simply the amount of time that is passed in between each frame, which is our delta time. And now what I can do is say if elapsed time is greater than a particular interval, such as maybe every 2 seconds, 1.5 seconds we want to spawn a leaf, then I want to take our leaves array and push in a new leaf. So I'm going to grab where we're already creating a new leaf with new sprite, paste it into leaves.push. So we're pushing in a new sprite at this coordinate, at this velocity. I think it's okay to make all the leaves have the same velocity. That's kind of like as if the wind is consistent. I know the wind isn't always consistent, but yeah, I think it'll make a good effect if we keep the velocity the same. But I do want the x and y values to change. So that way we're just not spawning the leaf from the same location in the top left-hand corner somewhere at 2020 up here. Rather, I would have the leaves spawn within the area of the trees. If I were to go over here, the area of the trees, I want our leaves spawning anywhere within this red rectangle. So we can kind of get an idea for where that is by guesstimating, I suppose. We don't want to use these static values anymore. Instead, we're going to use math.random times something like, I don't know, like 150. I'm just going to assume 150 is the width of this rectangle. And what math.random does is it gets a value 0 to 1, totally random. But if we multiply that by a larger value, such as 150 in this case, well, now we're going to get any value from 0 to 150, anywhere across this canvas right here. That's pretty much all it takes to get a random value. We just multiply math.random by a larger interval. And we can do the same thing for our y value, though this is going to be much smaller. Let's just say y is equal to 50. And we want to spawn this at a random y location with math.random times 50. So now, whenever elapsed time is greater than 1.5 seconds, we'll be pushing in a new leaf. But we're going to keep pushing in new leaves unless we reset elapsed time after this has occurred. So now, I'm going to reset elapsed time equal to 0 when this happens, and we should see a consistent amount of leaves spawned every 1.5 seconds. So let's refresh, and I'll close the console, see how it looks. So every 1.5 seconds, we now have some leaves coming in. Though these are disappearing a little too quickly for my liking, I think all I need to do is expand the amount of time in which these leaves are alive. And to do that, we can go to sprite.js. This is kind of where that interval is occurring. Change this to equal to something like 15 like I had originally. If we want to be smart developers, we always call this static value something, so we can come back to this and remember what it is we're dealing with. So 15 is also equal to leaf life interval, I suppose I would call it. And that works for me. I'm going to replace the static value with the constant. Now we should get a really cool effect with all these leaves disappearing. We got garbage collection in place for when we have too many leaves. Yeah, I'm loving the way this is looking, and eventually they should fade out after 15 seconds. Hopefully we see exactly that. And there they go, they start to fade out. So looking awesome. I wouldn't do anything different maybe except spawn more leaves, but really adds a great dynamic effect to our game. So that's how we use particles using new Sprite class. So I think this really gives you a good start to creating some sort of Legend of Zelda game. You know how to create a map, you know how to add enemies, you know how to do game over, you know how to remove enemies. I'm very happy with the amount of content that has gone into this. Of course, we could take this further, but I don't want the tutorial to honestly take forever as well, so maybe we'll go over more concepts in the future, like how to enter rooms and talk to new characters and so forth. But I think we're at a good point right here to start cleaning up our game to a more polished product at least. And that includes really just removing these default sprites that are still stuck there from MapperMate. And to remove these, well, it should be pretty simple, I believe. Let's just go to Sublime Text and check out our data folder. So if we can recall, we need to think, where did we put our enemies and where did we put our characters within our layers? And I believe we put them all within L_characters. So if we look inside of here, we're going to have a ton of zeros, but we're also going to have a few instances of a non-zero number. And really, what we need to do is find the locations near the bottom rows in which we had enemies rendered out using MapperMate. So these bottom 3 rows, or maybe 4, kind of represent the bottom of our map. And you can see we already have a few instances where there's not a 0. So I'm assuming the 13 is the dragon and the 14 is the bamboo. If we wanted to remove those renderings from our game, because now we have actual monsters in there in which we can attack, we can replace the number values with 0. So I'm going to do that for these 2 rows right here. And then I can save, refresh, and now when I go down towards the bottom of my map, you can see that those renderings are removed. Looks a lot better with just that. Something else I would remove is the original ninja character, because now we have a movable one. Maybe we want to move our ninja to that location. We probably will do that in this episode. Why don't we go ahead and just try guessing. I think the 7 right here might be our ninja. And it was not. It was a little girl. Okay, so you kind of get the idea of what's going on here at least, but I'm pretty sure this 1 is the ninja. Save that after changing it to 0, and yeah, the ninja is now gone. There's no duplicate. But maybe we want to move our ninja to this original location. It's kind of weird that we're starting up here when this is supposed to be our house. To do that, we can go to our mapper main map and find our location of where we placed our ninja originally. And if we hover over that location and look at the bottom left-hand corner right here, we have coordinates related to where this is within our map. And you can see the coordinates are 160 by 128. So where we're creating our player within index.js, we can change these values to the ones specified here. And they were 160 and 128. So x should be 160 and y should be 128. Now when we go back to our game and refresh, we're placed in that perfect position. And if we try walking around, well, it looks like our collision detection might be a little tight there. Maybe if I change this by adding 1 onto the pixel, yeah, that immediately fixes that issue with just immediately colliding in a collision block. I just don't think that was like a good user experience to immediately walk down into a collision block. But yeah, now you get the idea. We're spawning in this location. We can start removing the enemies from our map and so forth. So I think the last thing I would really do here is I kind of imagine this scenario where we're in this town, and by default the game starts you off with just the town under attack with monsters already in the town, and you just have to go start removing them. So I'm going to keep these enemies here, but I'm also going to add a couple more strewn throughout this town area. And we can do the exact same thing we just did with our player to find those locations. We can just hover over where we might want an enemy spawned. I think right here is a good one. And then we look at the coordinates in the bottom left. So that is 288 by 256. We would want to create a new monster within index.js. So I'll find new monster, and I'm going to create 2 more. And I want to make sure that I'm using separate ones. So 1 bamboo and 1 dragon in this case. And what were the coordinates in which I want to place these? Well, the first one is going to be 288 by 256. So 288 by 256. And let's put the other one down here. 144. And what was the second value? It was 336. So we'll go back to our game, refresh, and we should see those new monsters as well. So there's one in the middle of town. Can't really pass him till we get rid of him, and then there's another right here. It's just so cool how quick we can add these monsters now, given the way we set the game up. So yeah, that is how we are going to create the beginning, at least, to a Legend of Zelda style game. Hope you guys enjoyed, but let's check out the finished product. Thanks for watching, everyone. If you'd like to continue your game development journey, I recommend checking out this video next. It contains tons of knowledge on how to develop your own 2D platformer, and I will see you there. Enjoy.